live from the SAP Center in San Jose. This is NVIDIA GTC Live. Over the coming days, the world's leading developers, engineers, scientists, and founders will gather here at the center of the AI revolution. For the next 3 hours, we'll hear from the pioneers, the architects, and the builders transforming every industry. From robotics and research to global AI platforms, every layer of the computing world is being reinvented. All leading up to the moment we've all been waiting for. NVIDIA founder and CEO Jensen Huang takes the stage to define what comes next.
Welcome to GTC!
So settle in, you're not going to want to miss a moment. NVIDIA GTC Live starts now.
Welcome to GTC Live. We are kicking off NVIDIA's 4-day GTC conference where developers, researchers, startups, and industry leaders gather to explore the latest advances in artificial intelligence and accelerated computing. Everyone's starting to arrive for Jensen Huang's keynote address. But first, we are here to bring you the pregame show.
We have the key builders of the age of AI here with us today. Get ready for a lively and in-depth conversation about the technologies shaping the AI era, creating intelligent agents, robotics, autonomous systems, and the infrastructure around the world to power it all.
I'm Sarah Guo, founder and managing partner of Conviction, an AI-native venture firm where we partner with founders building the next generation of intelligent software companies.
And I'm Gavin Baker, founder and managing partner at Atreides Management, a crossover fund investing in high-growth tech and consumer companies with a focus on AI, SIMMs, and other emerging technologies.
AI isn't just a feature of the global economy, it's the engine, reshaping how we build, explore, discover, and manufacture on a planetary scale.
AI has moved from experimental to essential. It's rewriting the rules of industry, redefining security, accelerating science, and retooling manufacturing all in real time.
This show marks the 1-year anniversary of the first GTC pregame show. Last year, the pregame show was a small production tucked into a corner of a balcony here at the SAP Center. But since then, GTC has traveled the world, Paris, Taipei, Washington, DC, and back again today to San Jose, where it's literally bigger than ever.
Visionary CEOs, founders, and scientists are here to build the future, connect with each other and you. And there's one common thread. It's all accelerated by NVIDIA.
The GTC pregame will bring you 5 panel discussions with tech's biggest names covering accelerated computing, how AI is becoming essential infrastructure, how open models power the ecosystem, how agentic AI is at an inflection point, and finally, how AI is entering the physical world.
No question, this is the place to be if you want to know where artificial intelligence is headed.
Just how huge has the GTC pregame become? What better way to show you than from the sky?
And how awesome is it that we are outside this year, Sarah?
It's amazing. And, you know, this stadium usually houses tens of thousands of Sharks fans screaming about hockey. Now they're all equally, same level of energy about token throughput, compute access. I love it.
Same level of energy? I mean, I feel like this is next level, all due respect to the San Jose Sharks.
I'm sorry, better level of energy.
Yeah, we have an arena filled with token maxers.
And what an amazing production. To help us cover it all is our special GTC correspondent, Tiffany Jansen, who's out there in Arena Green. Tiffany?
Thanks, Sarah. Hi, everyone. I am here in the pregame lounge, and can we just take a moment to appreciate this? I mean, first of all, look at all these awesome couches, chairs, coffee behind me. Not like it's necessarily needed, though, because the energy here already is incredible. Now, I got here, I think it was around 7 a.m. this morning, and there was already a line of people waiting to get in, which is incredible. And now you can see the line behind me. It's even bigger, and it's going to continue to just get bigger and bigger before the keynote. Which, speaking of attendees, you know, they come from all over the world. I go to a lot of different conferences and events, but I can tell you with certainty, this is the biggest. People come from everywhere. When you go into a room, the energy is just electric. You hear people talking about different business deals, future of technology, starting companies. I mean, you can't help but feel so inspired. Now, today, I'm going to be taking you along for some really incredible conversations with some of the biggest names in tech. We are going to be talking about everything from agentic AI, physical AI, which, by the way, is a topic I am very excited about right now. I mean, over the past year, the idea of, a humanoid in my house being able to do laundry for me, I need that, like, really badly. We're going to be talking from everything from energy, autonomous vehicles, and so much more. Now, these conversations are going to cover not only what these thought leaders, these tech leaders are focused on right now, but what they are thinking about when it comes to the future of technology. We see it moving so quickly. Last year at GTC, I remember thinking to myself, there's no way NVIDIA can outdo themselves. But this year, they have. The energy here, one thing I really noticed is last year, the kind of energy was more so, okay, what's next? What's coming up? Now, this year, it's more so, where we see the results, we see how fast it's moving, where are we going to take this, what are we going to build next? And that is so exciting. And I think a lot of the conversations today are really going to cover that, so you know where to put your focus, what's coming up next. And as I mentioned earlier, the robotics, that is something that I personally am very, very keen on. Now, I think with Jensen's keynote today, it's going to really focus and shape as to what's coming over the next decade, really, where these technologies are headed, how these enterprises are building with them, which is something extremely excited. Now, I can hear behind me the crowd, the line. I mean, I remember last year there's some bridges that are going like 10 minutes, 20 minutes past the venue, and people are still lined up. It's really incredible. So stay tuned for some of those conversations I'll be having, but in the meantime, I'm going to throw it back to the stage.
Thanks, Tiff. Looking forward to it. Accelerated computing is driving breakthroughs in science, transforming manufacturing, and advancing healthcare. It's turbocharging how engineers imagine, simulate, and refine the technologies that shape our world before actual fabrication even starts. What began as a way to render pixels has become the foundation of a new era of computing, and its moment has truly arrived.
For 30 years, we've been advancing accelerated computing. We invented CUDA, and we observed its moment has now arrived, irrespective of AI. It does image processing, computer graphics, it runs SQL, runs Spark, it does data processing at speed of light for our government, for national security, and for enterprises around the world to find insight from it.
EDA to SDA, system design automation, to CAE, we're able to do simulations at a speed and scale unimaginable in the past. This is going to expand the market of computing into the world of design and engineering for the very first time.
You tell us what you need to have run, and I'm fairly certain we have an amazing library for you. NVIDIA's GPU is the only GPU that can do all of that, plus AI.
Here to unpack this pivotal moment for accelerated computing are Mark Edelstone, Managing Director at Morgan Stanley, Dinesh Nirmal, Senior Vice President, Software at IBM, Aki Jain, President and CTO at Palantir US Government, and Anirudh Devgan, President and CEO at Cadence.
Mark, I thought we'd start with you. You've been involved with NVIDIA as long as anybody outside the company as the analyst who took them public. It was quite a risk for you at the time, given 3D graphics was not maybe the best industry in the world. I'm just curious, what did you see in Jensen? What did you see in the company to make you take that risk? And I'd love some anecdotes from the early years.
Yeah, certainly it's been an amazing ride from the very beginning. I first met the company back in 1996, and it was an interesting start. So they had just basically done their NV1 and NV2 chips. Didn't go so well. And so I met some other people and began to think about them much like the other 60 or so 3D graphics and 2D graphics wannabe companies effectively that were coming to market at that period of time with their products. I met Jensen a year later, 97, completely turned things around. It was pretty amazing what they did. They brought out their Riva product line that just completely transformed the industry. And so, you know, what I saw there was this company that had this incredible view that you got to build platforms. Basically, it's a combination of architecture, algorithms, software, compatibility, and do that over and over and over again. And so they really just changed the whole environment of what we had seen historically, where in this market for graphics, everybody would leapfrog one another. And so companies could maybe hold together 1 or 2 generations of success, and then the next player would come in. And NVIDIA really just changed that. And they changed that in part with a whole different approach to how they'd bring products to market. Jensen would basically call that 3 teams for 2 seasons. And back then, effectively, you had fall and spring refreshes for PCs in the graphics marketplace. And so ultimately, people would just kind of miss a product window, and then therefore they would kind of lose their position in the market. That 3 teams for 2 seasons really changed it. So you constantly could leapfrog yourself and do it faster and better than other people. The vision at the beginning was basically that of computer vision that ultimately then transitioned into accelerated compute. And the story has just continued to get better and better ever since. So just tremendous combination of vision, technology, roadmap, execution that really has allowed this company to stand the test of time. So at the end of the day, I didn't take that much of a bet. When I met the people and understood what they were trying to do, it was pretty clear to me they'd be very successful. Now, it wasn't that prescient to know that it would be the most valuable and most profitable company in the world, but you could see that they'd have long-term success.
And now it's more like maybe 9 teams for 4 seasons with all the products they have.
It's such an amazing expression of a platform company, and it was amazing foresight of yours, Marks. Dinesh, you have been part of a platform that's reinvented itself over multiple generations of technology. When did you start as a company paying attention to this generation of AI and say, we need to do it again?
I think if you look at today, for the generative AI revolution as a platform to continue, I think one of the core elements is data. And the reason I say that is because if you look at the data in the past, it was always data as an endpoint, meaning you have data stored in a database, you write a structured query language to extract the data. Today, data as tools, I call it, meaning you have MCP servers that is enabling access to data. There's multiple tools that's available for you to go access the data. Data is chunked and stored into a vector database, all those things. And for the platform vision that you talked about to come alive, tomorrow I call it data as code or data as skills. The reason I say that is because, so let's say you have a document that you want to extract something. Today you just say, how much did I pay for my phone? It extracts from the document and you get an answer. Tomorrow you want to do the same thing. When I talk about data as code or data as skills, what's going to happen is you can go to Claude Code and say, create me a program or an application that enables you to do that. That is the trick, because that enables you to, one, flexibility. Because now the next time you have the same set of questions or different questions against the document, it can modify the code rather than regenerate the code. So the flexibility is there. 2, optimization and scale, right? Any platform, a data platform for generative AI needs that. How do I optimize it? How do I scale it? And the third is the velocity and the veracity of the data that's coming. I mean, if you look at enterprises, I would say 90% of the data is unstructured. How do you correlate with your transactional data is where the value is. So that platform vision to come alive, I would say 3 things, right? I mean, we have gone from endpoint to today, which is tools, and tomorrow, how do I create data as tools, or data as skills, or data as code? So I think that transformation is what we are excited about. That's where I think the future is, and how do we unlock that value for enterprises where 90% of the data is sitting in unstructured, and how do we correlate to the transactional data to bring the real value out?
It makes total sense that you would have the early insight building, as IBM was, the data infrastructure for all of these enterprises and saying, aha, we finally see that be it tools or skills, is going to get a lot cheaper, a lot more accessible, a lot more powerful from here.
Exactly. I think that's where the future is, because there's no shortage of data. I mean, the chats that you're doing, the documents that you're creating, everything is data. But how do you really create the value for that data is where the enterprises are struggling, because how do we make sure that, there's so much transactional data happening, but the velocity of data or the volume of data is coming from unstructured side of things. So every enterprise is looking to say, how do I really create value on the unstructured side but also bring the transactional correlation to really make generative AI reality, especially on real time.
Awesome. Aki, first, thank you for keeping America and our allies safe. But second, would love to hear, Palantir is, I think, eponymous with AI at the application layer. And would just love to hear, when Palantir started, what AI could do, where we are today, and what you think we'll be talking about next year at GTC from a capabilities perspective.
Yeah, no, absolutely. Thanks for having me. And I think kind of the points Dinesh made are really critical. If you go all the way back to the origin story of Palantir, we kind of, as a bunch of software engineers, were doing, in order to enable insights into that transactional and unstructured data, recognize that we need to be able to treat data the same way we did software. We needed things like revisioning. We needed the ability to actually put structure on it, similar to original object-oriented programming, and to make that really accessible to end users in order to enable humans, right? And at the time, AI was not, it was not mainstream, right? There was a whole lot of, AI exoticism, back in the early 2000s. And unless you were a really, really big, internet company who had lots of data, right? You were Google, something like that. It was really hard to actually leverage machine learning in ways that drove ROI for your business or for your mission. And so we really focus on the data problem and making data relevant to humans, curating it, and enabling large teams of humans to operate on that data together, similar to how software engineering teams worked. And so if you fast forward to kind of like 2016, 2017, where computer vision now, on the back of NVIDIA's investments and deep investments in CUDA and GPU, all of a sudden became a lot more useful, right? This is when Elon said, hey, we're going to do everything with computer vision and autopilot, and we don't need these types of technologies. We can do it in the low swap form factor. On the government side, that became really interesting, right? And on top of NVIDIA's GPU infrastructure, working with a number of companies, the ability to bring those computer vision models to keep soldiers and sailors safe when they're doing their missions kind of became a really core part of what we're doing. But the way you do that is with data, right? And both the unstructured, so unstructured isn't just text, it's video, it's audio, it's pictures, as well as text. Putting all that together with your transactional systems in order to enable the AI to actually make sense of your ecosystem. And I think where we are today with generative AI and a lot of where we've invested with AIP and closely with NVIDIA and the team has been a function of saying, we have all these systems, we have the ontology, we have the ability to understand the organization through data right now. We know how to onboard humans to our organizations. How do we onboard our AI teammates to work closely with humans hand in hand to actually accelerate a set of outcomes, but then to do it in a way that's governed, that's secure, and that ultimately scales, right? And we kind of think about it as we're moving into a generation of technology where the limb fact on scale for an organization is not just neurons, it's now electrons, actually, right? And the more electrons we can pump through to actually accelerate and scale out our outcomes, the better. And that's really kind of where we're focused right now with kind of the next couple of years.
I am going to ruthlessly adopt limb fact. It took me a second to figure it out, but I love it. Yes, limiting factor. But it would be great to hear a very specific example, maybe with your forward deployed engineer model for the last 3 months, where Palantir was able to really help kind of a mainstream Fortune 500 American company.
Yeah, absolutely. So one of the things we've really started to invest in is what we call AIFDE, right? So these are AI forward deployed engineers. And the whole concept of forward deployed engineers early on was to say a lot of organizations and companies don't understand how to model data, how to actually build an ontology in a way that's going to be useful to answer their long-term analytic questions. We've all done this. We've built 5-year schemas and roadmaps of organizing all our data, and on day 3 you abandon it.
It's very hard.
Right, yeah, it's got to be iterative. And so really, working a good example of this would be some of our work with GE Aerospace as an example. In 2024, they're really focusing on actually modeling. So building the simulation modeling around a particular engine. They kind of presented this, I think, last week at AIPCon. They were basically explaining how they started with modeling and sim to actually have a digital twin of the capability. From there, they actually took it and they built ontology around it to be able to understand all the parts, components, and different elements that went into it. And then they kind of extended that all the way to their supply chain to have kind of full end-to-end understanding of how should these engines perform when they don't and they're out of band. How do we actually start to get ahead of that from a supply chain perspective to build capability to get ahead of it? If you can now do that not just with humans, but with FDEs, which we're really investing, that are AI-oriented, so it's a human plus AI, effectively an AI FDE, enabling them to now scale and do that for the next 10 components. So what used to take, it's all about compression, what used to take 3 months will now take 3 days, because you have that ability to scale out. That's a tangible example of something that we've seen in the last 3 months leveraging generative AI.
Aki, I have so many questions about reasoning in such a mission-critical field, and you know, thinking about these different areas of engineering and operations that Palantir is working in. But maybe the other pinnacle of humanity's engineering prowess is chips and chip design. Anirudh, you run the platform that enables the platform, right? Can you talk a little bit about what Cadence has been doing to enable more innovation in chips and how AI has changed your workflow to date? I think everybody at this conference hears continually about coding agents and the productivity and power that comes from them. But for this area of engineering, are you seeing the impact?
Yes, absolutely. I mean, we have worked with AI and NVIDIA for some time. You know, we have partnership with NVIDIA for the last couple of decades. And it has really accelerated in the last 5 to 7 years. And there are 2 parts to that partnership. One is what I call design for AI. You know, our software is used to design NVIDIA's GPUs and most of the AI systems in the world. And the second part is AI for design. You know, we can apply AI to our own products, like you mentioned, and the effect can be quite transformative. You know, I think one thing, of course, we've seen application of AI to coding, you know, software, you know, C, C++ coding. But in chip design also there is coding. There is system Verilog and RTL. You know, it's less known as register transfer language. So once you have that, you know, we have all kinds of tools over last 20 years which optimize and generate the chip. But in the past, we have not able to generate RTL code or RTL test benches. So with agentic AI flows now, we can generate that top layer and then put the automation that has always been there below it. So I always said for years that you have to look at it as a 3-layer cake, you know. And the top layer is AI, now agentic AI. The middle layer is ground truth, you know, things like physics, chemistry, you know, how molecules work. People forgot that's important too. You know, and then the bottom layer is compute and data, like it was mentioned. So any successful application, a vertical slice of this cake. By the way, the reason I call it a cake is unless you're 2-year-old, you have to consume the slices together. So it has to be AI plus ground truth, you know, like the fundamental, how physics, chemistry, and then compute and data. And that definitely applies to chip design, like just like it does to other slices of that cake.
So Anirudh, what will this mean in kind of the most specific way for semiconductor design? Are we going to have better chips? Is the pace of progress going to accelerate? Help us offset the slowdown or end of Moore's law, depending on who you talk to? Are we going to be able to design, you know, more chips more cheaply? Like what is this going to mean? What does the future hold?
Yeah, it has profound implications. So first of all, on Moore's law, some people say is completely dead, some people say it's alive. I think what you have to remember is what parts of Moore's law is completely alive is area scaling. You know, maybe performance is not improving, but the chips are getting smaller and smaller. You know, you go from 5 to 3 to 2 to 1.4 to 1. So every generation, there are double the transistors on the chip. Okay. So that's likely to continue for next 10, 15 years. And further accelerated by 3D IC, you know, just like Blackwell, or you can pack more chips in a package. So as a result, the size is going to explode. You know, it's going to be 10, 20, 30 times bigger than now. And the history of chip design is always the workload is exponential. See, sometimes people get worried, okay, if you are too efficient, does it change the way the things are done? You know, like, do you need less tools because, you know, tools are 10 times faster? But in case of chip design, the workload itself is exponential. So we need 10x just to keep pace with that exponential. And this is the history of chip design. You know, if you look, you know, Mark has witnessed this just like I have over the last 20 years. You know, our software has made chips design 100 times better, but still there is more design and more activity. So I think to keep up with this exponential, we have to get 10 times better, at least 10 times better with AI, just to keep on that exponential complexity.
Aki, I want to come back to you just because Palantir has been going for a while, serving some of these very risk-sensitive, or at least very serious customers. I think we talk about this period as the era of maybe the year of accelerated computing becoming mainstream. How does more capacity, or the exponential that Anirudh and NVIDIA as a platform enables, how does it enable you to do more? Are you compute constrained in the use cases you have?
Generally, we're not necessarily compute constrained, actually. I mean, really on the government side of things, we're generally capability constrained, right? Getting the same capabilities that we can pull out our phone and use into the hands of warfighters and analysts and operators that need those tools to have some kind of compelling edge in their mission is traditionally been the area that we've seen be the limiting factor.
And sorry, when you say capability constrained, you mean in the product sense for the military sense versus the model sense?
Yeah, well, no, actually both traditionally. I think that's changed actually, which is why this is so exciting. I think if 15 years ago, when we were kind of getting off the ground, there was massive disparity in what was available to those users versus your traditional commercial or kind of public or private sector users. Now what we're seeing is there's a very, very short lag. In fact, it's incredible how quickly this technology is being leveraged. And so to that degree, then you do start to become compute constrained, right? And I think kind of on Anirudh's point, from a work perspective, there's only more work to do. There's only more data to analyze. Like these are not the things that we don't have. And so what's really cool we're seeing right now is that traditionally the problem has been there's been a lag in the software side, and there was tons of hardware, tons of comms. Now the software end is actually, the baseline is actually quite similar, and so now actually compute and scaled compute for the purposes of these missions are probably the limiting factor. But the data, the mission, the space, the humans, those are all available in abundance.
Dinesh, I would love to hear from you. I've heard Jensen say that all enterprises in the future are either going to be token producers or token consumers. And I think kind of the logical conclusion of this is if you're not a token producer, your fate as a business is going to be entirely determined by how efficiently and effectively you consume tokens as an organization. So I'd love to hear from you, because I know how many companies IBM works with. What are some common features of your customers that are successfully consuming tokens?
Yeah. So I go back to the data side of things. So if you look at enterprises, I would say there's 3 or 4 core things they look at, right? One is security. Obviously, it's very critical. Scalability. How do I scale? And that's where the tokens piece comes in, because it's not just producing and consuming. How effectively and efficiently are you doing that? Because there's a cost associated with it. The third one is reliability, because once again, coming back to the token, if the answers are not correct, it causes even more damage for an enterprise. So if I go back to the billing question, which is, what was my bill last month, and why did it go by $5? Now, when you ask that question, obviously everything is a token, but when you ask that question, you're expecting the correct answer. Not somewhat correct answer, but accurate answer. If you don't get that, you as a consumer is not happy. Immediately, what do? You cause some damage by putting it on Facebook or wherever else. So for every enterprise, it's not just about the token, but the reliability of that answer becomes so critical. In this world where we live in, where the data information flows so fast, it's so important, that reliability. The last piece that I would say in that token producing piece is responsibility, meaning, can I answer why that answer was given? In the generative AI world, it becomes a bit more harder, and that's where the companies like IBM, Palantir can come help, because the explainability of that answer becomes so important. Why did I produce that answer, and how do I, if a regulator comes, especially in the regulatory industries, you got to be able to explain why you made that decision or you gave that answer. So 100% right that token producing and token consumption is important, but the work that needs to get done, and this is where Palantir, IBM, others are excelling, because you got to take that data that's coming in, the ingestion phase. How do I clean that data, make it trustable, and make it available for these models to eventually for a consumer to use it as token consumer or producer? So one more example, and then so if you go back to the past, right? it was all about events. Everything at an enterprise is an event. And events are causing a lot of data. But events also was a consumer and a producer. You have a producer of events, and you have a consumer of events. And that's where Kafka was born. Kafka took off. Same thing is happening here, right? I mean, you have a token producer and a token consumer. But in that process, the reliability of answers matter, and the responsibility or explainability matters.
So in the same way that effectively, Claude Code, to me, the reason coding really exploded as this use case is people figured out how to have a really good harness for it that gave the model the context and maybe not as much explainability, right. But there's a big opportunity to build harnesses for every use case imaginable.
Correct. And even on that, to touch base, that's a really good point that you bring up, which is, it's not about producing code. I mean, you can use Cursor, you can use Claude Code, you can use, many tools out there as an IDE to produce code. But what is the quality of that code? Because if I'm spending more time fixing that code, then I don't get the value. So that's why many vendors don't talk about the quantity of the code, but they're more focused on the quality. Also, how do I get tasks done? Meaning I want to go from Java 7 to Java 17. What used to take me 1 month, can I do it in 2 days? So I think it's moving from code production, because everybody can claim I created 30,000 lines of code. But if that 30,000 lines of code is not good quality, then you're spending even more time fixing it. So that's where the focus is going to be. How do I make sure? That's why I said the reliability matters. How reliable is the data? How reliable is the answers? How reliable is the code? I think that is where the focus is, and that's where we are really helping enterprises.
As enterprises work through this hinge moment of, struggling through the usefulness, productivity, interaction mode with these models, can we look ahead a little bit? Mark, you have been watching this company and this industry for 20 years. There's never been more attention paid to semis and its impact on all of us. If you were going to make a prediction on, the next era of NVIDIA and what it means for all of the businesses that rely on it, what would it be?
Well, I think we're still quite early in this revolution that's happening here on AI. Obviously, it's been initially on training, moving to inference, but the whole world of physical AI is yet to come. And when I look at what NVIDIA is so good at, which is driving parallel computing, taking advantage of their platform approach to things, where you really have to enable the entire ecosystem, that's what I think we'll see, tremendous growth for them in the future. And so far it's been amazing. You look at this company and how they've evolved over time. It's been pretty spectacular, and I think we're still early on in terms of its evolution.
I can't wait to have my own multiple robots in my house. And hopefully that happens later this year or sometime in 27.
Yeah, it is amazing. You were talking about the early days of having 60+ competitors in the graphics space. It's kind of unthinkable to people looking at semis now that it would be so competitive. But the idea that you're just chasing generation after generation, transitioning to a platform and an ecosystem. What I'm hearing from you, Mark, is actually Jensen would tell us we're at the beginning of another S-curve around inference, and you're saying you definitely see one beyond that in physical AI.
Absolutely. Yeah, I think inference is still very early days. We've obviously taken a tremendous amount of infrastructure build that's been happening to drive training, but the reality is we all want to basically take advantage of those models. So that will be inferencing, but I think there's a whole nother wave that comes past that. And we see it now with early days of automated cars and things of that nature, but I think we're very, very early in terms of how we'll use all this intelligence at the edge.
I'm a huge believer. Thank you so much, Mark and guests. It's been a great conversation. Our friend Tiffany will be with us all day with some amazing folks. Tiff, who are you with now?
Thanks, Sarah. I'm here with Dan Ping, who is the VP of R&D at Siemens. Dan Ping, AI isn't just transforming software, it's also transforming the physical world, and Siemens plays such an important part in that. Can you expand on some examples of this at scale?
Oh, yeah, sure. Tiffany, it's great to be on your show. We live in a digital age. The cell phones we use, the cars we drive, the tools we use generate tons of data, which contains vital information to the success of a company. But to extract those information, we need a piece of smart software, algorithms, so that we can make sense of the data. And that algorithms is called AI. AI models like large language model has been very powerful and versatile, but at the same time, with its breadth, it comes with its weakness. It's like jack of every trade, master of none, right? It needs to be combined with the domain knowledge, and fortunately, we have this agentic AI. So today, with agentic AI, we can actually build in the domain expertise of people working in the industry day in and day out. And then we can actually using the MCP, using the workflows, and we suddenly empower the people who do not necessarily to be tech savvy. This is a game changer, right? This is very, very important. You know, at Siemens, we are in the manufacturer business. Our software is run by the thousands of manufacturers, from the design, simulation, to the manufacturer floor, to the supply chain management. And we know how hard it is to achieve that. With AI, with GPU, we can do much more and do it faster. Right? At Siemens, at CES, the Siemens CEO, Roland Busch, and Jason was on the stage. They announced that there is going to be a joint partnership between Siemens and NVIDIA in 4 areas: the AI in simulation, AI in supply chain management, AI in manufacture, and AI in EDA, right? So I came from the EDA industry. I can say a little bit more about the EDA. So for years, the designers has been using the EDA software to design the chips that is faster and better. With GPU, the GPU is like a monster, right? Compare with the chips you find in the iPhone. And today, we are using AI and GPU to design GPU. We do this by leveraging on, we run the physical simulation on the GPU with much improved speed. We use AI to build the process model with unprecedented accuracy and speed. So this is one area. The other one area is we do use generative AI and agentic AI to control our workflow so that the software will think and take actions. That's very critical. Right?
It is. And Damping, one thing you mentioned is just how quickly these workflows are speeding up now due to this. I really want to cover quickly here about digital twins. Do you have an example of a company that is using digital twins and you've seen the workflows accelerate?
Yes. At Siemens, working with NVIDIA's Omniverse, we built this tool called Accelerator. Now, the teams across the globe can use this software in a virtual environment with realistic, in the world. They can change the design, they can tweak in, make decisions. That is great.
Damping, thank you so much for that example and for your time. I am so excited for what Siemens is doing and what comes next. But for now, I'm going to pass it back to the stage.
Thank you, Tiffany. Thank you, Tiffany.
Just as electricity powered the industrial age and the internet powered the digital age, AI infrastructure is the transformative driving force driving the next wave. AI requires a new kind of computing, purpose-built systems designed to produce intelligence at massive scale. Here's a look at how AI is becoming the foundational infrastructure of the modern world. We're joined now by leaders building that global infrastructure. Michael Dell, founder, chairman and CEO, Dell Technologies, our second year in a row, Michael. Michael Intrator, co-founder, chairman and CEO of CoreWeave. Lynn Chow, co-founder, CEO of Fireworks AI. And Joe Creed, the CEO of Caterpillar.
Michael, you are a legend at understanding the hardware business that comes with each technical revolution. You were there for the PCs, for the cloud. Now with AI, you are building these gigantic data centers, and yet there's also renewed interest in having a ton of compute at the consumer edge with OpenClaw and these types of projects. How do you think about where the distribution of compute is going forward?
I think it's going to be everywhere, right? The debates over the years about, on what side of the network does computing power grow? And the answer is both, right? It's kind of always been both. But now with autonomous agents, certainly we see tons of distributed inference growing. And 2 years ago, we introduced the Dell AI Factory, right? And we had customers that sort of knew what they were doing, but a lot of customers needed help. Now we have this AI data platform with an orchestration engine to organize all the data. That's incredibly important. Of course, the infrastructure continues to evolve and expand at an incredible pace. And we have the GB300 in the workstation level and increasingly powerful machines that can run these autonomous agents all the way to the Vera projects that we're doing with Mike and many others. And it's incredible to see the pace of the build out, and the demand for compute and inference is highly distributed. Tons at the edge, tons in smaller data centers, and tons in the larger data centers too.
I think one of the things that's really striking for everyone on this panel is the new level of scale you are figuring out how to operate at and able to enable this ecosystem, right? It's not a single unit, it's a factory. The complexity and engineering in that is something that you're enabling tons of other people to take advantage of in partnership.
Yeah, and it's a combination of course, all the advances in compute, but also the network fabrics, the storage. We built a whole parallel file system, our Lightning file system, the fastest file system in the world. You got to feed these GPUs the data super fast. And as the networks grow, and of course, KV caching is incredibly important as you get more complex queries and multi-agent systems. And so having this sort of layered memory system with KV caching is in some ways the growth of the memory and storage and data is more than the compute itself, because of the way the algorithms work. And a big plot inside the enterprise is, how do you unlock all this cold data that has never really been used? And this is what we see happening with these 4,000 plus customers now. They're figuring out how to activate that data and really make this real inside their businesses. But it's a lot more than just hitting a button and all of a sudden you've got AI. You've got to organize the data and curate it, and also work on the processes in a company to make it effective. But we're now seeing thousands of companies do this, and I believe we're still at the beginning of it, actually.
You make this really good point. I was thinking about just the overall scale of the clusters that we are being asked to build today, but the fact that it is a memory hierarchy problem, a system software problem, a model caching problem, a power and dirt and electricity management problem. I think it's incredibly amazing what the ecosystem has put together, and I think we sometimes overly focus on this one really powerful thing, which is how much matrix multiplication can we do?
And importantly, bringing all the data together, because in the previous IT architectures, you had silos of data, hundreds or thousands of them inside a large corporation, and there was never any reason to bring all the data together. Well, now there's a reason to do it.
Absolutely, and an insightful observer who we're going to hear a lot from, maybe I guess in 90 minutes, described it as a 5-layer cake. And Mike, you are CoreWeave, Mike. You are an important part of that cake, and would love to hear. I think a big focus of today's keynote is probably going to be the disaggregation of inference into prefill and decode. What could this mean for your business?
Yeah, it's a great question. It's going to be one of the important themes that we're going to be focused on here and kind of as we move forward. It's like such a fascinating panel because it's giving you and we were talking about this in the back, a real insight into how broadly this is impacting every aspect of the economy. So it really does stretch beyond compute, stretches beyond data centers down into the energy structure, all the way up into inference. And so, it's a fun panel because it really kind of touches on so many of those thematic requirements to deliver the AI factories. I get really excited about the deconstruction of the workloads because it allows a company like CoreWeave to really kind of laser focus on each aspect of that to be able to optimize in areas that perhaps in earlier waves of computing it didn't pay because it wasn't at the order of magnitude that required that level of specialization. As far as the depreciation question you were asking, it's really interesting because what will happen is as you go about deconstructing these workloads, the ability to route the portion of the workloads into those part of the computing architecture progression will allow for extracting more value from existing infrastructure, right? And so what you're probably going to see is folks begin to pair older generations of GPUs to pick up certain portions of the workload while the most bleeding edge, tech-forward components of the infrastructure stack are able to really deliver on those like computationally enormous workloads. And so I think that, talking my book a little bit here, of course, but I think what you're going to get is, once again, a realization that there's a lot of different workloads that are coming to the market, and a lot of those different workloads will enable us to extract value from the installed base as well as the base that we're installing as we move forward through time, which leads to the ability to extract value in excess of the depreciation cycle that we're working on, which we're really excited about. And, we've built our company around being able to really target how we go about using this infrastructure.
Absolutely. I believe firmly the disaggregation of inference is going to lead to an extension of useful lives of GPUs.
Love that.
Because you can put a decode optimized solution in front of a 3-year-old Hopper, a 5-year-old Ampere, and get a lot more tokens out of that, out of those old GPUs. That's going to be great for GPU residual values, useful lives. And who would have thought that the disaggregation of prefill and inference was going to save the private credit industry? Because those 4 to 5 year useful lives people underwrote to might be 8 or 10 years, and those financing rates are going to drop, which will be great for everyone.
Yeah, listen, the more value that can be extracted from each dollar invested into the infrastructure, certainly the better it is for the lenders, the better it is for the credit stack. But it's also really great for new use cases that are coming into existence, because what it does is it allows ideas and new companies that may have been struggling to get their hands on or access to infrastructure to build whatever their new vision was or whatever their new company was. And it's incredibly important for all of us to be able to seed that next generation of companies, right? And if they can't get access to the compute that they need to build their companies, to drive their companies, to monetize their ideas, it's bad for the ecosystem at large. And so, I think it's really great as you move through the stack to extract more value from what we have already invested. I mean, those dollars are out the door, they're in the data centers, they're in the servers, they're in the supercomputers, they're in the energy infrastructure. We need to milk all the value from that we can to be able to invest in the next wave.
Absolutely. Getting more compute out of what we have is lower financing rates. It'll help us get the 1,000x more compute we need, the 100,000x more compute, or even more. We need to finance this.
I think one of the things that is sometimes forgotten is that there is several magnitudes more incredible engineers working on the efficiency of models and the ability to use, one generation behind or smaller clusters in terms of running models that are incredibly powerful. There's two magnitudes more people working on this today, right? I think you have these two curves of people chasing capability and people making it accessible. And I think the ability to benefit the entire industry from making it accessible is a really important thing. Lynn, if inference is going to increase 1,000x, or as Jensen says, maybe 100,000x from here, today it's still dominated by a couple large labs. Your business is about enabling other people to run their own inference. When does that transition happen? When do they begin to care about owning it, or what other attributes matter?
Right. We start to see increasing, significant, explosive increasing adoption of customized inference. Fireworks is on the critical path of delivering that value, and we provide customized inference with customized model for purpose-built for applications. And before we talk about, 2026 is the year of efficiency, I would like to talk about 2026 is the year of explosive innovation, AI innovation that's happening. And we can see that from demo to production scale, it drops from multiple quarters to multiple days, and OpenClaw is just the poster child of beginning of this journey. And Fireworks, we massively agentize our day-to-day workflow. This can generalize the whole entire industry, where we build our recruiting agent to source top-tier candidates, and our finance team build agents, use Fireworks to automate finance forecasting and budget planning. Our legal team are using Fireworks to build their legal tech. We develop inference software, and we use coding Copilot massively. And what we see is across the whole entire industry, the tools are getting better. And therefore, agents can build more efficiently on top of new tools. And tools get further better, and the new agent get emerged to replace old agents. So there will be a huge amount of energy in the application agentic space to continuously innovate. And the whole ecosystem will take some time to settle down. And we're really happy to power all this innovation at light speed. Now, talking about 2026 as the year of efficiency, we have seen the explosive usage, consumption of token from our own company and from all of our customers. And it's kind of interesting phenomenon that now today, having product market fit doesn't mean having a durable business. It's very strange, because in the typical SaaS era, having a product market fit, you just scale as fast as you can. And today, there are so many cases, whether they're startups or incumbents, they will literally scale to bankruptcy. So this is because fundamentally, inference is not as cost efficient yet as before, because the whole entire supply chain, we are going through the evolution of being operational efficiency. All the way from the software stack to hardware to data center to energy, the whole entire system is going through this revolution. I think we are all working together. Everyone is all working together to bring down the cost to the cost of ownership. We are approaching this in a very unique way. What we think about this is we don't think application or agentic builder should be API wrappers. They should activate their private data produced by their application or locked inside an enterprise to bring their model to the next level of intelligence, and use that to also make the model faster and a lot more cost efficient. So this is something we call three-dimensional optimization that Fireworks produce as a unique way of approach the problem. And we can bring down your TCO by 5 to 10 times. At the same time, we're also working on cutting-edge technology. We're thinking, why we separate out model training from inference? We should all mix it together. While your model work with your application to do inference, your model should continue to learn the specific pattern from your application, therefore to make it faster, better, and more cost-efficient. So we are working on a lot of those cutting-edge technologies to bring customized inference into fruition. And obviously, our innovation will not happen without significant innovation from all of the technology at basic infrastructure level. And particularly, we are very excited about the new Rubin and Grok integration because this is a massive disaggregated deployment at hardware level. But we also think, hey, when we blend training and inference together, we can also do a lot more aggressive disaggregation, as in every single bottleneck, they shouldn't be blended together. They can scale completely independently to drive the maximum amount of efficiency. So this is an extremely exciting time for us and to see all the impact building on top of us and work with all of you to drive the innovation here together.
Awesome. So Joe, thanks for being with us here. The world is structurally short wafers and watts. And we just heard a lot from your fellow panelists about how we're going to get a lot more tokens out of the wafers we're making because of the new technologies that we're going to hear about in a little bit. More tokens per watt means Jevons paradox. We're going to consume way more tokens and way more watts. So if you thought the world was lacking in power before, look out 12 to 18 months. But I know you guys have been increasing capacity. So Joe, can you just talk about how Caterpillar, in that 5-layer cake, nothing can happen without that bottom layer of watts?
Sure. I mean, I think it's amazing, again, this panel to be up here. You think about founders of tech companies and everybody that's here, and that as a 100-year-old industrial company, it shows really how widespread AI and what we're seeing with technology in the world. I mean, the infrastructure build-out is going to be like nothing I've seen in my almost 30 years of career at Caterpillar. And I love how Jensen lays out the 5 layers, and you talk about energy and chips and infrastructure, those first 3 layers. I mean, that's what we enable at Caterpillar, right? We are construction, we are mining, and we're power and energy. So when you think about what our customers do, we need critical minerals for chips. That's through mining. We need iron ore and copper to build data centers. Our construction equipment builds the data centers. Our power and energy equipment, we're massively short on enough energy and watts to keep up with this build out. So we kind of refer to ourselves as the invisible layer that kind of supports all that infrastructure build out. And I think it's just an incredible time for a 100-year-old company to be looking at what we have in front of us and how we play into this, into the bottom 3 layers of that. What's also kind of fascinating is for Caterpillar, we're also using the top 2 layers. We're big users of the technology as well. So when you think about, we just launched an AI assistant for our customers. We're going to launch it in the cab of the machines to be an operator coach later this year. And so our mission is to solve our customers' toughest challenges. And the things that I hear from our customers are, hey, first off, job site safety. Same in our factories. We want our employees and our customers to be safe. Shortage of operators. We need to be able to quickly train operators and have coaches in the cab for them. And then also job site efficiency. There's a lot of inefficiency in our factories and on job sites where we can use digital twins and AI to really unlock a lot of value here. And so, as users of the technology, I mean, we are just at the cusp of really getting out there, putting people at the forefront and moving them, from the dangerous jobs to where they're overseeing equipment working instead of necessarily in their, in the cab. And just having coaches. I mean, one of the things, Mike and I talked about this last night, there's a lot of talk about the power and having enough power infrastructure to keep up with the growth that we have, but we need more skilled labor. Our customers are struggling to get operators. We're trying to help them through autonomy solve that challenge, but we need more electricians, we need more technicians to work on our equipment, and so we're making big investments in the workforce at the same time because right behind power, I believe, is having enough skilled labor to really keep up with this huge demand that we have for infrastructure across the globe.
That's awesome. So AI is not only creating jobs, it's creating better, safer jobs.
Absolutely.
And we need that AI to meet the demand we have for watts and wafers.
Absolutely.
Makes sense that you would be investing in, these supply gaps on labor that we can't solve. Beyond that, how else are you making Caterpillar go faster, right? Because you can't train new people to match a 1,000x or 100x demand. What else are you doing to compress the bottleneck in the physical construction?
Yeah, so we have a number of things going on. One, we're just trying to add enough capacity to keep up with the product and the demand that we have. But internally, changing how we work and how do we use technology, and now we're moving to inference. How can we embed it inside our company to help our people develop product, move faster? How do we take the inefficiencies out and get people off of sort of mundane tasks? You'd be surprised as a 100-year-old company, the processes we have and how many opportunities I think that we have in front of us that we've barely even scratched the surface on, of really making our people more efficient and kind of elevating them out of what I would say is kind of mundane work and putting them into where they use their mind and creativity to really move the needle. So I think for us, it's going to really be super impactful for our culture and just how our people work every single day, both in the office and in the factory and in the field. You think about our technicians that have to support, and our dealers' technicians supporting customers in the field, having quick access to an AI assistant to diagnose problems, remote monitoring and diagnostics for us. So they show up ready to get customers back to work, and that's what we're focused on.
I think it's a really important point because, organizational structures and systems are a function of the tools that were available at the time they were created, right? And now we have this incredible breakthrough technology that is evolving rapidly, continuing to advance. And so how you get to the outcomes in 2029 is very different than you did, in 2019, right? And so you really have to reimagine the entire processes from a tops-down standpoint to get to the outcomes, and then you get incredible speed inside your company, and you better do that, or else you're going to get destroyed by somebody who does.
100%. The third quarter was actually the first time that we saw kind of real S&P 500 companies in a variety of industries talk about AI-driven productivity, have it show up in their financial statements, and have the stocks go up significantly. C.H. Robinson, a trucking company, was a big AI winner in the third quarter. But it'd be really helpful, kind of maybe a little bit of a lightning round. And maybe Michael, since you posed it, you could go first. But what's the most specific, mind-blowing productivity gain you've seen at your own company in the last 6 months through AI, where you were just like, wow, I didn't think we'd get that until 2030, and it's here now?
So many examples. I could take the rest of the panel. I won't do that. But the one that I'm most excited about is the speed of innovation, that, from idea to product delivery in our product groups, right? So 20,000 plus engineers enabled with the latest tools, and they're able to do things in 2 weeks that would take 9 months, right? And so that is making us a far better company, and we're just innovating at scale much faster, and that is super valuable. And when I think about all companies sort of on that path, I mean, that's just an enormous speed up for drug discovery, solving all sorts of unsolved challenges out there, and ultimately, as we get these better tools, we're going to do more. The economy's going to expand.
Absolutely.
Michael, are you seeing that kind of speed up in such a real-world, operationally intensive business?
Absolutely. So one of the great things about this panel here is that, for me, is that I'm getting affirmation that every single part of the stack is seeing similar types of challenges, similar types of hurdles that they have to address in order to maintain the pace of the build-out of infrastructure. And whether or not we ultimately hit Jensen's lofty numbers of how much more compute is required or not, directionally, that is where we are going. And so the challenges that all of us are going to face are going to be sustained. One of the things that I do believe is that when you introduce new technologies like this, they tend to come from the fringe inward towards the core of what a business does, right? And that there's numerous different.
Who's the fringe right now?
So you start out with, you know, hey, I'm going to make my email a little bit better. I'm going to do this. I'm going to do that. And then all of a sudden you start to see AI presenting itself through engineering, right, in the coding. And you know, when you ask me about, like, you know, what's astounding or what's magical around artificial intelligence, when I sit with my CTO and he says that, like, basically, unless I'm on a phone call, I'm 10x more effective. These are pretty talented engineers to be able to magnify the impact of those engineers who are building this by 10x, unless they're you know, working with a client, going through the kind of normal cadence of how you build a business. That's incredible, right? And so my expectation of how our company will feel the impact of this was that you start on the margin and kind of work your way down towards the core of what a business does. And so you're going to see, you know, just enormous strides in terms of the velocity with which we're able to drive our technology stack, the software layers that sit on top of it, how we go about configuring our data centers to optimize and future-proof them so that we're able to support not just the current iteration of technology, but into the future. You see it working its way through HR so that we are not hiring for tasks, but really hiring for people that are going to be able to carry the company forward. All of these things are driving more productivity and more scaling within our organization. And I think that that's probably a progression that you see across industries. And I'm, you know, like, we're still years away from where it's going to really get to the core of some of our heavy industries. It's just going to take some time, and it's just really exciting.
And absolutely, I think we're tracking well ahead of Jensen's lofty predictions from previous GTCs, so let's hope we stay on that path.
It'll keep us busy.
Thank you so much to this group. You guys are the builders behind the builders, so we are counting on you. And thank you to my awesome co-host, Gavin.
Thank you, Sarah. Thank you, team.
Thank you.
Thanks, everybody.
Thanks, guys.
Let's check in with Tiff and see who she's talking with backstage.
Thanks, Sarah. I'm here with Claudia Blanco, who is the Chief Innovation and AI Officer at GE Vernova. Claudia, you know, when we think AI, we're really starting to realize just how much AI and energy are converging. What are some opportunities there for GE Vernova?
Thank you for the question, Tiffany. And first of all, I'm really glad to be here today with all of you. So we are in a unique moment in time, right? So we see, like, large AI data centers are demanding more power, more energy, and it's where we came into the intersection of things, right? So we need AI for AI, actually, is what I like to say. So how those large data centers will require energy when the power system requires the combination of things to happen, right? So from how to generate more energy to how to transfer this energy with more capacity, but also how the distribution can be done more efficiently, right? And also combining with sustainable solutions. So it's a large mix of things that has to happen at the same time to make it work. And AI at the same time play a key role. So at the time that we have to provide this power system and all that is required to make it work, it's also very important to know that AI can help a lot to manage the power systems, right?
Absolutely. I love that you said AI for AI. I think I'm going to steal that from you. I'm going to use that one. You know, I'm curious to get your perspective on this. What are some parallels when it comes to the energy grid and AI infrastructure that you're seeing?
A very interesting question, because actually we see that parallelism. If we think about how the power system infrastructures were built 100 years ago, it was a unique moment as well. Many things had to happen, right? From the power architecture to be built to also the transmission systems and also the subsystems to the distribution, as well as the automation and control at the edge. So all of these had to happen 100 years ago, right? And we see something very similar today with the AI infrastructures, right? How the large data centers will require a combination of multiple things to happen as well. That would require a big transformation. So how to merge the power supply, the power systems with computing, with also, all that is going to be the cooling systems and the infrastructures management of an AI data center, it will require also a big transformation. So I see a very important parallelism there.
Absolutely. I think it's so important to be able to look back. You mentioned 100 years of energy grids and taking learnings from that into our future and what we are building next. I'm curious to get your take. How is software really reshaping energy management?
Yeah, as well, this is something that is going to be critical for us. You know that with AI, actually, we can give, for the first time, the capabilities to our operators to manage the grid, to manage the power system in a more intelligent way, right? So, which means that if we provide this intelligence, power system is a complex system, right? So it's a large amount of data to be managed at the same time that system, hardware, physical system at the edge, and then how can you operate that in a larger scale, right? So AI will provide ways to handle this massive data in a more comprehensive way, more intelligent, and it's where it will play a key role. And connecting to the previous question, I think the AI factory concept play a key role here, because we will start designing from the beginning the infrastructure required end-to-end, merging all those systems, power systems, with what the AI data centers will require.
Absolutely. Claudia, thank you so much for shedding some insight on that. I am very excited to what the future holds. But for now, I'm going to throw it back to the stage.
Thanks, Tiff. We'll check back with you in a bit. I'm now joined by Sequoia Capital partner, Alfred Lin, who will help lead us for the remainder of the show. Welcome, Alfred.
Thank you, Sarah. Thanks for having me here. Thanks, Jensen. Thanks, the NVIDIA team. You guys did a great job leading up to this. This is awesome. It's a bright day. It's sunny. It's awesome to spend time with you, too, because usually I spend more time with your husband.
Well, one of us has to work today. It's great to be here with a friend, a OG NVIDIA investor, and a co-traveler as we try to figure out what's happening in the next wave of the ecosystem, which we're going to talk about now.
Yeah, well, yeah, Sequoia has been very, very fortunate to be an early investor, seed investor in NVIDIA. And Mark Stevens made that investment, and he's still, even though he's retired from Sequoia, still on the board. And so we're very, very fortunate to be associated with NVIDIA. I wasn't there when the NVIDIA investment was made. That was just genius. But when I joined Sequoia, I did check NVIDIA's stock price, and it was a quarter. I think Jensen's added $180 to that, which is 721 times return in the last 10 years, 15 years, 16 years. So it's amazing. It's an amazing company.
It's pretty cool to see also, hearing from Mark at the beginning of the day, what the journey is from a competitive market of, 60 vendors fighting about graphics to platform company with 3 S-curves in front of it, and we're maybe in the beginning of the second one. I cannot wait to talk to some of the companies we are speaking to in the rest of the pregame about the platform journeys they're going on.
Yeah. And you guys set it up so well. We had the accelerated compute, the infrastructure. Now we're going to talk about open weight models and systems, about AI agents, and then we're going to end with physical AI.
Great to have you here. Before we get to the next chapter, Tiffany's got another great guest on deck. Tiff?
Thanks, Sarah. I'm here with Alex Atala, who is the co-founder and CEO of OpenRouter. Alex, why is openness so important when it comes to AI innovation?
A vast majority of the economy is going to move towards inference and compute. And a major principle we want to make sure is true in that future is that we have competition in the economy around inference. Open models allow multiple companies to compete to build incredible inference for the models that come out of model labs. And what that results for the end consumer and for businesses is faster inference at higher quality and more interesting integrations. And you just need an open economy to enable a really competitive future for that. And open models are the way to do that.
Absolutely, I couldn't agree more. Open models. On that note, when it comes to developers, how are you seeing developers navigate so many different models today?
Developers tend to follow the vibes, which most people are familiar with.
I like that.
They do look at benchmarks, but we find that happens when a new model launches. We've observed something that we call the Cinderella effect, which we wrote a paper about last year, where the first cohort, the first week of developers, there's a section of it that figures out what the model is good for, and they stick to it. They have the highest retention among all cohorts that follow them in the future. So they discover these novel use cases or what these open models are good at, and then they stick to them. And what we do is try to expose those insights to the rest of the world, so people can see what the power users and what the LLM enthusiasts are doing with these new models. We also see that closed models tend to boost the total addressable market for a particular use case, and then open models come in and help people reduce costs, which becomes a huge thing when you realize, wow, our costs are ballooning. All of our developers are doing crazy things we didn't expect.
Absolutely. And was this Cinderella effect? Is that what you call it?
That's what we called it.
I like it. I need to read that paper. That sounds very fascinating. I'm curious, what startups are you starting to see emerge?
We're seeing a lot of startups try to re-envision how to organize a company now with AI agents. What will it look like when you actually try to give them responsibility and when you try to give them full context? Because these two things are the two big gaping holes in AI today. AI agents don't have responsibility for anything, and they don't have the full context of the company. So we're seeing more startups try to work on those two problems. We're seeing a lot of startups just try to get more integrations to AI agents so that they can, act on behalf of humans in different places. We're seeing a lot of interesting agents emerge to just help developers improve their productivity, help developers manage multiple workflows that are happening simultaneously. A lot of startups are realizing, whoa, I have the problems that 100-person companies usually have, and much more.
When it comes to AI agents, what is an example, just a quick specific example with AI agents that you're seeing a startup use them for?
Very specific example, I could just think of all the cases our own company is using them for.
Yeah.
We're building agents to help our sales team prep for calls, very bespoke agents that run automatically before the calls happen, so that they know everything they need to know about who they're talking to. We have agents around auditing for security. We have security audits running constantly, all the time, on all PRs for code that was merged in a week ago. And we have, now we have interesting roll-up agents that are just kind of running ambiently in the background and looking for interesting insights in our data, what apps are emerging. We have data about public apps, apps that opt into public visibility, and we expose all this data to the world in our new apps rankings and in our models rankings.
Thank you for those examples. I love hearing specific examples because it really gets me so excited as to what other companies are working on, what people are thinking about. And we're going to continue a lot of these great conversations, but for now, I'm going to give it back to the stage.
Thank you, Tiffany. We'll check back with you soon. AI's impact won't come from chatbots alone. The real breakthroughs happen when developers take open models and build on top of them, adapting them to new industries, new problems, and entirely new kinds of applications. That's why open models are so important. They give developers, startups, researchers, and enterprises the freedom to experiment, specialize, and push AI into new frontiers. So what happens when open models meet a global community of builders? Let's dive into our next chapter.
Open source models have become incredibly useful for developers. They are now the lifeblood of startups. Researchers need open source. Developers need open source. Companies around the world, we need open source. And so NVIDIA is dedicating ourselves to go do that. Each one of the industries have its own use case, its own data, its own use data, its own flywheels. All of that capability, that domain expertise, needs to have the ability to embed into a model. Open source makes that possible.
Here to discuss how open models drive innovation, expand the AI ecosystem are Aravind Srinivas, co-founder and CEO of Perplexity AI, Arthur Mensch, co-founder and CEO of Mistral AI, Robin Rambach, co-founder and CEO of Black Forest Labs, and Aidan Gomez, co-founder and CEO of Cohere. Welcome.
Welcome, everyone. First, let me start with Arvind. You had a very, very successful launch with Perplexity Computer, and you've described it as a computer that should be, the personal computer that should exist in 2026. I wish I had that, where it runs 20 agents simultaneously. It helps you do a whole bunch of things. Tell us about your launch. Tell us how it's going. And tie that back to open models. How are you using them? And how's that helping the ecosystem?
Yeah. So Perplexity Computer is an orchestra conductor of everything AI can do today. It runs in the cloud. And all the musicians in that orchestra is basically all these different frontier models, the connectors. They're playing a music that's equivalent to the work that you want AI to do for you on the computer. One other way to think about it, as a person doing work on your computer, what do you really need? You need a browser, you need access to the internet. So giving AIs access to the internet was the core idea of Perplexity. And then giving AIs access to the browser was the core idea of our Comet browser. Now we complete the puzzle where we gave them access to a file system and a code execution sandbox and 20 different models, hundreds of connectors, a lot of CLIs. Turns out when you do that, AI can become a director, directing all these sub-agents to do all your workloads for you every day, asynchronously, always on. So that is the core idea of Perplexity Computer. Open source has always accelerated new applications, and open models naturally fit into computer. We're already using models from Alibaba, the Qwen series, and we're going to be using a lot more. So models in our mind, as far as computer is concerned, are just tools, just like the file system or the code sandbox or these connectors or the CLIs. Models are just tools. What actually matters is the orchestra.
And how are people orchestrating computer today, Perplexity Computer?
So many different applications. People are building their own mini versions of Bloomberg Terminal that's connected to their own portfolio that they have access through the Plat connector. People are building web applications that famously monitor the situation around the world, whatever is going on. Because you have access to the internet, you can create your own live streams of what's going on. You can build applications that pull internal context. Our entire company, Perplexity, is just running on Slack, where this computer is yet another person on Slack that is just orchestrating these workloads. We estimate around $90 million worth of labor for our max users in the first couple of weeks of launch of the enterprise product.
That is really terrific.
There's such massive increase in continuous agent usage that obviously requires compute behind it. Arthur, Mistral has always had models that punch above their weight from an efficiency perspective. We just had a panel talking all about 2026 as the year of efficiency. Where are you seeing demand for this in your own customer base, where people care not just about max capability, but efficiency?
I mean, the demand comes from all of our enterprise customers. It depends a little bit on the vertical, but efficiency matters when you're deploying agents at scale, and then suddenly you care about token cost and you care about the unit economics, and that's where we build open weight models so that our customers can have cheaper access to that technology. So it matters for cost, also matters for the UX and the experience generally, because when you have a small model, it can actually go faster. And if it goes faster, you can solve your task faster as well. So that aspect around latency is actually critical. If you lower the latency, you can actually change the kind of applications you're building. And so when our customers are building for their own customers, it typically is a problem because they want to have low good UX, and good UX means to have specialized models that are small enough. There's a big use case as well that we target quite significantly and that we work with a lot of companies, which is edge deployment. And edge deployment is about mobile deployment, but oftentimes it's also about putting models into robotic systems, into industrialization systems, into factories. And so you need to have these small models that have audio as input, that have video as input, and that can process that, and that can do it in a way which is fully disconnected. So we're actually announcing today Mistral Small 4, which is really punching above its weight in that respect, and it's a reasoning model that can actually be deployed on the edge in that respect.
Congratulations, that's super exciting. I think one of the things that is somewhat forgotten when we talk about use of models is you want this iterative loop, either in the model's generation and verification capability itself, or between the human. And then I haven't been waiting for computers for, I don't know, a decade and a half before the last few years, and now I'm waiting all the time, right? And so I do think efficiency is going to be a huge front of competition.
Yeah, if you put it that it's super important, and the other thing that is important is also to be able to modify those systems and to learn from interactions in between user and the models themselves. And that's where having open weight models and a way to access the parameters and to change them to steer the behavior is actually critical. When you go into the depth and the productivization of the AI systems, you actually need that deep access.
Thank you, Arthur, on the sort of importance of latency. Latency is very, very important for the creative world, for the generative AI world, and Robin, for Black Forest Labs, how are you reducing latency? How are you sort of supporting the creative community in their quest to make better and better content out there?
Yeah, I think for the creative community in particular, open weights, open models are super important because they are like more formable. We see that actually, and I kind of want to disagree with this take of models are just tools. I think models are a super important substance for the creative community. It comes, you can fine-tune them, you can like interact with them in all different kinds of ways. It's not just input, output. You can take them apart, you can plug them into like workflows, node-based systems, stuff like that. And then they go way beyond like creative community. It's like a basis for research, for innovation. I think it's fundamental technology and really not just a tool. For latency, yes, 100%. It's like one of the most important aspects of all kinds of models today. We work on it with like a lot of like distillation research that we do. And yeah, I think we are pretty good at like getting like the number of inference steps that you need with a diffusion model or flow matching model down to, let's say, 4 or something like that, which then really helps in combination with stuff like quantization to make these models really efficient.
You mentioned diffusion models. They started the whole wave for creatives and creative community to build things that they didn't think they could build as efficiently and as powerfully as before. What's next? What's on the horizon?
Yeah, I think it's really interesting that we see how especially like visual models are expanding in scope from content creation to simulation to physical AI applications. And it's like the shared technology underneath is like, yeah, or the technology underneath is shared, right? It's like the same or very related modeling approaches, but we're approaching new scales of data, of models and multimodality that then enables these models to expand into what we find really, really exciting physical AI, simulation use cases, real-time video generation.
Aidan, whether we look at these models as just tools or a moldable substance, as Robin was saying, they've been relatively hard to work with for most of the industry, even the engineering audience for the past few years. What are you seeing in your enterprise customers and the people you interact with about sophistication in terms of post-training and customization now?
It's increasing dramatically, and I think open source models are contributing to that because it gives the customer the freedom to explore and experiment themselves without having to depend on any other organization. One of the things I'm most excited about with open models is the notion of control. So Cohere does a lot of work with high security settings. Privacy is not just important, but essential for the customers that we work with inside telco and financial services, et cetera. And what open models do is give the customer the ability to choose where and how they deploy. So when we're delivering that technology, when we're delivering North, our agentic platform, we have to make sure that our models can be deployed on-prem, air-gapped, on-device, anywhere. And open models enable that. In terms of customization, I think that these models, they're fantastic general reasoners. They can be applied to pretty much any domain, anything, but there's a production gap that needs to be closed. There's a level of performance that you need when you're deploying into these extremely important high-stakes scenarios that you're not going to get out of a generic model. So the ability to customize and close that gap is essential to actual deployment and scale of the technology into the economy and the ecosystem.
I have a hot take question. There's this meme in VC that closed is easier to monetize, open is easier to mobilize. Do you agree with that? Is it easier to get distribution? Is it easier to work with so that you're not locked in because you're having to pay one or two closed models? What do you think?
Well, I think distribution at the end comes down to value you provide. For example, there were a lot of open models, but you could argue that the pivotal moment in open source among model providers was when DeepSeek surpassed OpenAI 01. That's when everyone started to go bonkers about it. So I would say like the same thing keeps repeating, like Kimi Moonshot, like I think even Elon called them out for their work yesterday night. So in general, closed or open, the capabilities are basically what fundamentally define distribution. And that's kind of why we've taken a position that we would use whatever is the best capability for each model and put it all into like one orchestrated system. One advantage, obviously, in open source is cost. Because you can take the model and do your own inference. You are obviously going to have a massive cost advantage serving that over paying a closed model provider. But what usually has happened over the last 2 years is every time there's a great open source model, the closed model providers always lower their costs, which is good for application layer companies like us. And we very much welcome that competition.
In terms of a follow-up to that, Arthur, since costs are coming down for closed models, how do you sort of stay relevant and continue to sort of push open source and be potentially a center for European excellence and sovereign AI for Europe?
I think what we find is that the value is in the integration in between the models we do and the distributed systems that we use to deploy the agents to make sure that execution is durable, observable, to make sure that the models can improve when the users are giving feedback. So at the end of the day, if you only bring an open model to an enterprise, it's not going to know what to do with it. But if you bring it the right platform with the right sandboxes, execution, with the right inference at scale that is efficient, and the right customization mechanism that they don't need to care about, they don't want to care about fine-tuning, they care about seeing the system improve over time. And so what we're really bringing to enterprises is the right level of abstraction so they can work on our open source models, on other open source models if need be, and make sure that they can actually create the business applications that are driving the ROI. And so the motion there, which has been successful for us, is to really bring that platform, but also bring the experts so that they work with the subject matter experts and actually customize the systems at a level where the ROI can be found. So that's the gap, bridging the gap between open weight models that effectively bring control and low cost and strategic autonomy. And the ROI that you need to have if you're running an enterprise or running a line of business is the gap that we solve, and it's the gap where we find where we build our business model.
Robin, as one of the creators of Stable Diffusion, one of the things that you had foresight into was this idea that's really attractive to me of latent demand that we can serve with these new tools. There's clearly latent demand for expressing creativity from the community that's begun to use these models over the last few years. Where else do you think people don't realize how much latent demand there is for creative tools? Like, what else should we imagine is going to come where people want to do it all the time, all day? I don't think everybody predicted that there were going to be that many people recreationally making images or videos.
Yeah, 100%. And I think making images or making videos is just like one application for these models, as I said, but like they are becoming more general. So I think like a lot of the demand it's actually not latent. It's like very obvious. Like if you look at like the frontier models today, having that capability available, open source, it's just like it's a no-brainer. You have to work towards that if you want to maximize distribution. So I think that's to answer your question of like distribution versus monetization. I think like if you want to maximize distribution, just make the most capable model and get that out there. And again, it's like a basis for like so much more than just image generation or video generation. And I think that when you have like an open model available and these use cases are getting explored on top of the open model, that really helps to unlock new use cases that then, I don't know, other companies implement on top of these models. And I think like one pretty important aspect, especially when you look at like agentic applications, is that there's a lot of like model in the loop kind of applications that will be enabled in the future, or that people are already working on, where image generation is a great example, right? Like that's one that is being productionized already, where low latency really helps you to make repeated calls to the model and then embed that into your product. For stuff like coding agents currently, I think there's like a lot of like, the work is being done to implement the code and then you make the product out of it. But actually going towards more efficiency and having like repeated model calls enabled all the time is, I think, something that needs to happen, and I think where open source can also really help.
Let's take us a little step back. You were one of the co-authors of the seminal 2017 paper about transformers, All You Need Is Attention. There's a lot has happened since 2017 in AI. What has surprised you the most?
That's a really hard. I feel like it's a surprise every 3-4 months that comes out. The extent to which we've been able to create a general platform for intelligence that can be applied in so many different domains is a huge shock. When we were building the transformer, it was built for Google Translate. That was the objective. That's what we were hill climbing on. I don't think any of us who were involved in creating the transformer had any foresight into what might come and how people might run with it. And I don't think we can take any credit for it either. I think it's really the community that picked up the transformer as a platform and carried it forward into all of these different domains.
And what's the blocker now for more and more adoption? Is it the infrastructure? Is it trust? Is it open weight models being more available, easier to use? What do you think?
Market penetration on the consumer side of house, in terms of like the average person using these models, seems to be well on its way to everyone will be able to use this model in the same way that they use Google for search, right? That seems to be quite safe and steady and on a track towards success. On the enterprise side of house, in terms of deploying this technology into global economies, there are huge barriers. There's the trust barrier, there's the privacy barrier, trying to bring these systems into an organization, give them the access and authority to take actions that previously we would only be able to consider a human for. Those sorts of trust barriers, I think, are the ones that need to be overcome. Privacy is a huge component of that. Sovereignty is a huge component of that. And it's something that, at Cohere, we're super excited to make progress on.
Great.
One question, Ervin, that I have for you is you expose the ability for end consumers to choose models in all your surfaces, right? The conventional wisdom, at least in venture, would be like the users kind of don't care what's underneath the surface. Is that? But because I asked Robin, this is surprising. I'm like Aiden. I'm surprised by everything in AI. I like try really hard to lean into capability. I'm still like, wow, it's a shock every day. Do you feel like users care, or why do they care? What are you learning from that?
I'll tell you an interesting stat. So first of all, Perplexity started as a consumer company, but an interesting emergent outcome is our enterprise adoption is growing fast, even if we don't want to work on it. So one thing that our enterprise users are doing, more than 50% of every user, not just the organization, is picking different models every day they use the product. They love.
Well, that's really powerful. They're actively making that choice. Most people are.
Yeah.
Okay.
So they can. So at the beginning of 2025, my worldview was models are going to get commoditized, and towards the end of the year, and I think different frontier lab CEOs are saying this too, that models are specializing. even within coding, people would say Claude Code and Codex are good at different things. And our engineers use both of them. So what's happening right now is models are specializing in different things. And so that makes the need for selecting models for different use cases very important. Of course, we're going to do that orchestration for you. But if you have a certain opinion yourself that this model suits my use case the best, you can go and pick it. And it's happening. The user behavior indicates it's happening. And it's one of the biggest value propositions of our app and our platform is that you don't need to feel locked into one vendor. And by the way, we are supporting both open and closed models here. Like on Friday, we brought up Nemotron, the latest open source model from NVIDIA. And they want to keep improving it. And we're going to keep putting all their newer versions on our app every time that happens. And that also unlocks a different kind of application, like people are talking about sovereignty and AI. You obviously need a model, but you also need the orchestration, the actual product that connects to your internal data, web data, proprietary data, all these different tools, runs securely on sandboxes. Like that's the work we've already done, except we can do it all with open source models too now, and that'll unlock like enterprise on-prem or sovereign applications for us.
Arthur, what do you hope in 5 years, if we're sitting here, what do you hope will the open AI ecosystem will do for the AI economy?
Sorry, the open space.
The
AI.
open AI space, yes.
So I'd say the reality is that enterprises, they don't really want to care about what's underlying. What they care about is indeed controlling the systems, knowing that nobody can turn it off, and they care about the things improving over time. And so to Aravin's point, today some of them still care about what model to pick, but eventually that's kind of a bug. It's just a sign of immaturity of the space, because what they want to have is really business applications that are solving their problems. And so when we use Mistral Vibe to actually do this kind of business applications and work with our customers to really create the software they need to operate their processes, they don't really care about it being open or it being closed. They care about having control. They care about that if we are to disappear, they actually can maintain business continuity, etc. So that's the sovereignty part of it. So eventually, I think in 5 years, the technology and abstractions that are needed to operate agents at scale, reliably, in a way that is self-improving, etc., this is going to happen. And we think there is kind of two worlds. Either a world where you have just a couple of players that are locking the space from model to orchestration to applications, or a world where you have a choice in between the different bricks of the platform that you can use. So you can choose your own infrastructure provider, you can choose your own models, you can actually see the code of the orchestration side and have enough transparency and control over the entire stack. And so in 5 years, I would expect that we'll come up with the right abstractions. That's going to be the Linux of AI, where you have open source inference, you have open source models, you have open source orchestration, open source coding tools. Everything is actually going to be quite cheap, because when it's open source, you can deploy it yourself, so it's hard to make margins. But the integration part is where the value is going to be created. Just like, I guess, Red Hat, for instance, has a pretty good business model there. So the bet that we're taking is invest significantly on making open source win, and then build the orchestration and the help that enterprises need to stitch all of these bricks together.
It's great. Well, at least there would be some money to be made with integration for the rest of us investing in companies. Robin, underneath Black Forest Labs, what open models are you using? Are they all from China, Chinese models, or are they all over the world?
We are making our own models, so we are primarily using them. We've actually been working with Mistral for our latest Flux 2 model. So there's like a VLM component that is able to process the inputs. That's the Mistral 3 model. And then Flux 2 is like our own from scratch trained model architecture.
And why did you decide to make your own model, since there's so many out there?
I think our models are more efficient and better. So I think that's, I don't know, like our ambition is really here to push the frontier of visual intelligence and these visual generative models. And I think to your point of like, how do you monetize these open models, right? There's a lot of talk about like open source, but then also about like open weight. And I think there's a case to be made for new business license models around open source or open weight models in AI, because it is so resource intensive, obviously, that you have to find some way. And for us, it's actually been interesting. We have like a lot of like open weight models that we put out there, and they are contributing like the majority to our revenue. It's more than our API that we host. And yeah, we keep iterating on it, but I think there is like a real opportunity to figure out something new.
Thank you guys so much. This is a great panel and core to the ecosystem here at NVIDIA. I did not realize that the commitment to open ecosystem came with a commitment to cool, dark sunglasses. Alfred and I will sign up next time. You got to send a text, guys. Come on. It's about the community working on things together.
Thank you, guys. Really appreciate it.
Thank you.
Thank you.
Time to check back in with Tiff out on Arena Green.
Thanks, Sarah. I'm here with Tuhin Shrivastava, who is the co-founder and CEO of Base 10. Tuhin, how are you this morning?
I'm great, Tiffany. Thanks so much for having me.
Thanks for being here. Tuhin, I need to know, what does it actually take to run models reliably at scale?
Yeah, absolutely. Look, you need to be able to have a lot of compute to start with. You need to be able to have a software layer that optimizes for both speed, cost, and reliability, and be able to scale with the customer as they grow things up. So, we work with great customers like Abridge and Open Evidence and Cursor and Lovable, and these are customers that are growing tremendously fast. And for us, what matters to them is, a software layer, a support layer, and a compute layer that can support their growth.
Absolutely. You just listed some huge customers. Are there any stories or examples that you can share from one of them?
Yeah, absolutely. Look, one of my favorite customers is a customer called Open Evidence. Open Evidence, powers a question answering service for doctors. It's clinical decision support. They've been growing incredibly fast. And what does Open Evidence need? Well, they're being used bedside by doctors with patients. And what they care most about is reliability, so it never goes down, and speed. And how quickly can customers get their answers, or doctors and nurses get their answers at bedside?
I think that's such a great example. I always lean on real world examples because it really hits home then as to how this technology and what Base 10 is doing impacts everyone. And I think it's so great when we focus on healthcare and how that is bringing so much benefits to so many people.
Yeah, absolutely. And look, we're seeing that across everything from coding to healthcare to sales and go-to-market. Literally, we're seeing an explosion of AI in every application.
Absolutely. You mentioned earlier speed, reliability, and cost. Where is the industry headed on all three?
Yeah, so look, on speed, what we are seeing is, especially for these agentic use cases or real-time use cases, latency needs to be as low as possible. So, we do a lot of work with NVIDIA to make sure these models run very fast. As an example, we use libraries like Dynamo and TRTLM to get these running, but, speed has to be as low as possible. Reliability is, we can't actually get these models integrated into real-world use cases unless they're working most of the time, if not all the time. And so reliability has to be very high. And cost is, look, as the cost of AI goes down, we're just going to see a lot more AI, and that's what we've been seeing is that, as new chips come up, we're getting a lot more efficient. As software gets better, we're getting a lot more efficient, and that's just driving down the cost, which at the end is just driving more adoption of AI.
Absolutely. Let's talk about the open model explosion we've been seeing recently here. How has that changed what your customers are needing from you?
Yeah, look, there's great closed models and there's great open models, and we serve both customers serving closed source models and customers trying to use open source models in their applications. What we see with open source models is that customers can own the end experience a lot more. So developers can build, go more verticalized with their customers, and so they can not only use how the models are trained and the weights, but also how they're optimized to be used and how task specific they are. So rather than have one model that rules them all, there are a bunch of small models that will be using for smaller tasks.
I love that. Very task specific, owning the full vertical. It's key, especially when you're thinking about growth and longevity.
Yeah, 100%.
Tuhin, thank you so much for your time. I'm really excited about what the future with open models holds and how Base 10 is playing such a pivotal role. I'm looking forward to more conversations with you, but for now, I'm going to throw it back to the stage.
Thanks, Tiff. Before we move on to the next chapter, a quick reminder for the attendees here. If you have a ticket for the keynote, head on inside and get your seat. You can still watch the rest of the pregame in there.
For the past few years, most people have experienced AI through chatbots. But the next phase of AI is something entirely different. The reason the term agentic AI is going to be on everyone's lips is that we're moving from systems that simply respond to systems that can reason, plan, use tools, and take action. AI agents are capable of carrying out complex, multi-step work on their own today. And that changes everything.
Frontier agentic systems have reached an inflection point for the usefulness of agents across the world and enterprises everywhere. There's 1 billion knowledge workers in the world. There are probably going to be 10 billion digital workers working with us side by side. You're seeing incredible compute demand because of it. In this new world of AI, compute is revenues. 30 million software engineers around the world will be AI assisted. There's the industry of applications that AI has created. It's a revolutionary technology. Healthcare, IT, manufacturing, every industry will be revolutionized.
Agentic AI is where AI begins to do real work, and the builders pushing the frontier are here to discuss this with us today. Please welcome Peter Steinberg, founder of OpenClaw, Harrison Chase, co-founder and CEO of LangChain, Vincent Weiser, co-founder and CEO of Prime Intellect, and Sam Rodriguez, founder and CEO of Edison Scientific.
Peter, we have to start with the man with the claws growing out of his head. You have created an absolutely viral phenomenon. Can you walk us through just a little bit of the story of what were you trying to solve and why do you think it resonated so much?
Good morning. I was trying to solve, sometimes you just want to talk to your computer. Like I walk to the kitchen and I'm like, oh, I need to do this little thing.
Hey, Jensen.
Hey,
Jensen.
Oh my God. Welcome to GTC. Good morning.
Jensen, welcome to your own party.
See you.
Hi. It's like an all-star
Good to see you. Wow, what an appearance.
What's going on out here? Look at this set.
We're warming this up for you.
This is incredible. Well, you guys don't get to watch it from the inside. I was just on the inside.
Was it good?
It's incredible, you guys. All these people are watching you guys. It's like, thinking like there are probably already 15,000 people in there.
Wow. Well, they're really here to see you.
No, they're here for the pregame show. This is just like a Super Bowl. The pregame show is better than the game.
Or at least louder. We dance a bunch, so I'm sure you've got some prizes
You guys
for
are
everybody.
awesome. Well, I'll tell you what, I got a lot to say. I've got to figure out how to get it all out, so I'm going to go prepare. But Peter, it's great to have you here.
Likewise.
You've started quite a movement.
Yeah, it's giving me a lot of sleepless nights.
And the NVIDIA team working with you?
Yeah.
They doing a good job?
We were cooking last night.
That's cool. That's cool. I'm glad to see you all dressed up and cleaned up, though. You were working all night.
Well, sometimes you got to do what you got to do.
Yeah, well, you should have, next time, have your claw do the work.
We're working on that.
Somehow the faster and the smarter the claws are, the harder we work. Have you figured that out?
We work hard.
We're in the critical path now all the time. I still, like back in the old days, I'll send off a project and I have to wait for people to work on it for like a week. Now I send off a project and they're back within 15 minutes. And so you're in the critical path again. I have a feeling, just like the internet made us all busier, I have a feeling AI is going to make us all busier.
You are making us busier.
Well, I'm definitely making you busier.
You're building AI factories that all these great people are building companies on top of. So
well, I appreciate that. Well, this is the Rockstar team. All right, I'll let you guys at it. I'll see you guys on the inside.
Thank you, Jensen.
Hey, guys. Hello. Wow, check it out. This is just like the Super Bowl. Thanks, guys. Thank you.
Go stretch.
There might be more people here to see you than the Super Bowl. Where were we?
I'm going to ask this question again, Peter. Okay, you woke up and you're like, I got to talk to my computer. And then?
You know, I wanted this since May. And to me, it was so obvious that all the big labs would be building it. And then months passed, and it was November, and there was still nothing. And I'm like, oh, do I have to do anything myself? And I just vibed it into existence, basically. And then ever since, it's been a rocket ship. But clearly, people want AI that actually does things. Like, you have your own identity. And now we're heading into a future where we make this possible.
Harrison, you've been building LangChain for a while to help developers so that they can deploy, build, and test agents so they can build reliably. We've had certain situations where they build very reliably, and other places where it's not building as reliably. You term the phrase context engineering. Tell us a little bit more about that and how you're making LangChain make agents much more reliable for all the rest of us.
Yeah, absolutely. Excited to be here. And we did not coin the phrase, but I like to think we were pretty early on board that ship. But
you can take credit.
No. When agents mess up, they mess up usually because the LLM inside messes up, and the LLM inside messes up usually because it doesn't have the right context. Sometimes it's just not smart enough as well, and hopefully everyone here who's helping build models will help make them better. But oftentimes they mess up just because they don't have the right context. And so a big part of getting agents or agentic systems or even just LLM systems to work is giving them the right context. And the interesting thing is we've seen kind of a transition from manual context engineering, where you pipe certain data to the LLM, to letting the LLM do more and more of the context engineering for itself. So letting it call tools, letting it decide what to remember, what to pull back from memory. And so everything's just context engineering at the end of the day, but the exact shape that it's taken has changed over the last few years.
How has developers sort of changed over the last year or two as agents have become much more capable? What are they building on top of LangChain? What are they trying to do to sort of make sure that they have the right harness to build upon?
So everyone always wanted to build this idea of an LLM running in a loop and doing things. And if you remember like AutoGPT from like 3 years ago, that's what it was. And the issue was the models just weren't good enough at the time to do anything reliable. And so we built a bunch of kind of like scaffolding around it. And from when LangChain started to maybe about a year ago, a lot of our focus was on things like LangGraph, which are these more deterministic kind of like scaffolding around the model. Recently, we've seen that with Claude Code and OpenClaw and things like that, the models are now just good enough to run in a loop and do things. And so a lot of it has become what we call kind of like harness engineering. How do you build the harness around the model? Because it's not like not everything's going to like collapse into the model, but the model will do more and more. And so the harness and the environment that it interacts with is really important. And so we've seen a big shift towards harness engineering in the past few months.
Vincent, you're helping a lot of people improve quality where the agents are still not yet sufficiently good. How do you decide with a customer where it's the harness or where it's the model itself?
That's a great question. Yeah, so for the context, like with Prime Intellect, we train agentic models and help customers to do so. And I think from like context engineering, I think there's a lot of work needed to basically scale reinforcement learning to make the models really good on the specific harness, on the specific use case. So I think the like Claude Codes of the world are great examples where ultimately having the harness and the shape of the terminal and scaling RL within that and then rolling it out to the users and using those production traces to further improve the model. I think it's like kind of like how you really scale agentic capabilities of models. And I think for different customers, like they care about different things. So we have like some customers who train also very general purpose agentic models. For example, one of our customers trained Trinity, which actually is like the, I think, second most used OpenClaw model on OpenRouter. So like those models, for example, are intended to have very wide use cases, but then others have a very narrow use case of, for example, automating spreadsheets and accounting. And then they just create the RL environment for that and scale within that, but then also by rolling it out and having the users interact with it, there's more opportunities to basically scale the capabilities much further.
One of the big questions about extending agents as they get more long horizon and in different domains is verifiability, right? It's sort of pretty intuitive that in math and code, even in perhaps parts of science where you can do experimentation, which we also want to talk about, you know what the answer is. How do you think about the next domains where there's some intuition on how to verify?
I think actually a lot of domains have some measure of verifiability. I think actually one of the ones I'm most excited about is sort of like automating AI research itself, which I think is also like a segue to Sam's work on automating science. And I think that will really also take agents, I think, to the next level. It's like I think having agents on the fly self-improve, like to figure out their specific environment and their context. Like I think to some extent, I think models are still stuck in this like static model era, and they're not continuously learning yet. They're not continuously improving yet. And I think that will be one of the, I think, most exciting areas. And I think once, like with, I think autonomous AI research, I think will move to a point when one can like synthetically generate RL environments and synthetically scale RL, for example. But I think over time, I think we'll probably like automate all of AI research, and I think that will probably really like get agentic AI capabilities to the next level.
This isn't quite research, but I have a job running right now, and we hope it's done by the end of the pregame. That is, it's an SFT job, and I'm like, well, if it doesn't work, just try again, figure out what went wrong. And so I think to your point of put it in a loop, we're going to get very far across customization with a bunch of more sophisticated techniques.
Yeah, I think like there was this sort of moment like after OpenClaw that Karpathy spawned with an auto research project, and I think it kind of like very quickly showed us, I think, like how easily you can actually improve model capabilities using agentic AI.
Alfred?
Sam, so you're building AI for scientists in biology and chemistry. Most of these guys are doing things that at least are, as Sarah mentioned, verifiable, or they're zero, one, they're binary. You can say yes or no to something. You're building something in the world of chemistry and biology, which is, I would say, maybe just probabilistic, distributed in some way. It's not easy to do that. How are you solving that?
Well, so I run Edison Scientific. We're building AI agents for science. We're focused in particular on drug discovery and drug development. And it's actually, science is at the end of the day verifiable, right? You run experiments when you're basically asking nature what is the answer, and nature tells you. So in some senses, we have some very good properties there, right? Unfortunately, the experiments that really matter when you're thinking about discovering new drugs are clinical trials. And clinical trials, yeah, you can get a result, but it'll take you 3 years or something, right? Or maybe 1 year or 2 years, depending. And so you really just have to find proxies along the way where there are subtasks that are verifiable, right? Where you can get evaluations from human experts, and then kind of bootstrap that way towards something that is capable of doing science at a human level, right, at the same level as expert humans, or maybe better than expert humans, but maybe not like full superhuman. And then ultimately, by putting it into a loop, which will take much longer, but by putting it into a loop, you can maybe get to like the full superhuman level, right? But I think this is just like one of the problems, like the more general problem here is just when you want to interact with the physical world, right, with the real world, things in the real world take time, right? And that's going to be a huge limitation for agents, and one of the things we're going to have to figure out.
You've mentioned in the past that right now the models are B-level scientists, and they don't have, maybe to Sarah's point, the intuition, the understanding, and maybe sort of the bridge between the digital world and the human world. How far away are we from getting models to be A-level intelligence in science?
I think not far, actually. So I forget exactly when I said that. Now I would probably say they're like A-, probably, right? So you really want to be at like A+, but it's coming along very quickly. And I think the critical thing to understand is that you get a huge amount of mileage from the fact that you can do the same things that the humans would do much faster, right? So even if an agent on an individual run produces something that's like A- level, but it can do it,
at scale,
100 times faster and at scale, then on the back end, you can just kind of screen for which of these outputs is passable, which of these outputs do we, is usable, and you still end up getting the benefit, which is that the thing is done in 1/100th of the time. And this is where we get into these idea of like, the agent swarms, the fact that you can run agents at scale can make up for the fact that any individual agent run may be less good than the best human in that space, right?
So Sam, what are you pointing as the sort of the #1 problem that you're trying to solve with Edison?
Well, what I tell people is science requires 3 things. It requires capital, logistics, and talent, right? Capital scales, logistics scales, talent does not scale. And so fundamentally, if we want science to scale, we need to be able to figure out how to remove talent as a bottleneck, right? And that's what we're focused on doing. And so I tell people, people talk a lot about lab in the loop, which means that you want to have the agents able to come up with experiments and then interact with robots to run those experiments. I actually think that's like insufficiently ambitious. What we really want is like clinic in the loop, where the agents are able to do everything that needs to happen in order to get the drug to the point where it can be tested in humans, and then you coordinate with medical centers to kind of run those experiments and then iterate. But we should really, in a matter of a year or two, be at the point where we can just like scale discovery of new medicines to a level that has not been seen before. And we, humanity as a species, like we don't have to live with disease. And I think that we will not soon.
That's a great vision for the future, where we don't have to live with disease and everything is happy and sunny like we are here today.
I think AI for science, and in particular medicine, is great as a field to think about, not only for its impact on us all, but also because it helps us imagine the level of ambition we should have in every domain, right? I think intuitively, Sam's like, well, we can solve these problems. We need a lot more science, and people understand that. We just don't have the capacity. Peter, you are hopefully living in a future, a year or a few years ahead of the rest of us. Everybody wants to know, like, well, are you working less? Do you kind of sound like you're working more? What are your claws doing for you? Like, what is it going to be like for all of us when we've really optimized our claw setup or whatever's next?
Yeah, I don't think we're going to be working less. I'm sorry. The future is just too exciting. I think we can work on more interesting things. Mm-hmm. Maybe model side A-, but they can really do a lot of the things that are a little bit more tedious. And then, at least when I look at the field of how software is being built in the future, because OpenClaw is also very much a prototype on how to build software much faster than in the classical ways. All these boring things that would have taken me so long, the agents can do now. And ultimately, I have to do more of the hard thinking, but I can move so much faster. We can move so much faster and keep it more interesting.
What's a boring thing you no longer do, or you do much less of?
Writing code. Now I think about the shape the code should have, or the features I want. It's actually now much more of a challenge of saying no, because things are so easy to be prompted into existence, but you still have to think about all the ramification, like where do you actually want to go? People talk about 10x, I think that's even underrated in software to a degree, but there's so much more still that's hard, where agents are just starting to also become useful. When I use Codex, I don't just do software, I also do all my knowledge work now. I don't click through Slack anymore, my agent clicks through Slack, finds all the threads, correlates it with my email, maybe some issue tracker, GitHub, and then tells me exactly what I need to do. And I can run 5 of these in parallel, and then just focus on the things that are really interesting. So the whole field of knowledge work is completely being transformed. And right now you see there's companies who really get it, and there's so many companies where the gap between what we could do and what is there is wider than ever. So one of the things I saw with OpenClaw is how, with software, people get it, but knowledge work still has this gap, and now suddenly people just figure out, oh, it can do my emails, it can check, it can actually go on this website and does all these things where ultimately we solve problems, right? And this domain of writing code now generalizes into, oh, it can solve any kind of problem to me. So that's super exciting.
So on writing code, Harrison, we know you to be a very good coder from your previous life. Are you coding?
My previous life, yeah.
Are you coding anymore? That answers the question.
I'm not coding. I'm not coding anymore. But I mean, even inside our company, we're thinking a lot about what like EPD, engineering, product, and design looks like in this new world. A lot of what you said really resonates. Like I think we're seeing that system thinking, whether at the engineering level or the product level or design. That was always the most important thing, but the amount of time you could spend on it was kind of dwarfed by the amount of time you had to write code or write a PRD or do a Figma or something like that. And now we're seeing that all that stuff is cheap. It's not perfect, but it's cheaper and freer. And so a lot of the bottleneck is choosing the right problems to work on. So I think everyone kind of has to have some sense of product and some sense of understanding, but then also having the right system thinking to say no, to point in the right direction, to make sure that everything that these agents are doing for you is building towards a cohesive narrative. And I think we're seeing this play out mostly in kind of like the engineering space because the models are really good at coding, and also like the environment for coding is pretty like buttoned up. Like you've got your GitHub repo, you can pull it down, it's all there. If you think about knowledge work, there's so many different systems you have to integrate with. It's less clear what kind of like that environment looks like. But we're seeing a massive shift in EPD.
How do you hire differently now that that shift has happened?
I think we've seen like two profiles of people be really attractive, and I'm curious for others' thoughts as well, but we see kind of like there's this like generalist, scrappy AI like power user that has product sense, has some kind of like engineering chops, and can take a problem, wrestle with it, and just go really far, and really high agency to do that. And then we still absolutely see that these like senior architects in product and engineering design to help kind of like bring some of that systems thinking and get that like initial like like idea over the line into something that's production ready. Those are the two archetypes that I think are having the most success with. I'd be curious for others' thoughts. We're still trying to think through this a lot. So.
Yeah, I think like I would share this. I think to some extent you need to like hire. I think for the like really AI native people, it's like sort of like one of my first interview questions is like how people use AI, and like it's usually a bad sign if they don't like properly use it. Like for example, if you interview a developer and they're not properly using like AI to develop, and I think there's like unique sort of like young talent that I think also has this like the opportunity to almost like leapfrog across the industries by becoming like early adopters of AI, right? Like I think it's not just for developers. I think it goes across every knowledge worker. I think like the talent that will be very AI native, I think will be much more interesting, I think, to all the companies out there.
Yeah, I've heard people talk about the fact that there is no front-end engineer, back-end engineer. You don't really need to be a specialist as a designer or a PM. There's just the concept of builders, and then there's build systems where you have great harnesses, and then live ops because you ship it and then you understand what's going on in the world.
I speak Rust now. It's terrifying. Nobody wants that. Sam, I have to ask you before we run out of time, when you think about this scalable A- scientist, and then the need to still physically do experiments and get data that we don't have yet, what is the role of scientists in your organization or across the industry over the next few years? Like, how is it changing? Am I just like physically running the lab and setting a problem until we can automate the lab?
Yeah, no, it's a great question, but I think like I agree basically with the sentiment that people are just going to be busier, right? So fundamentally, there are a few things that humans kind of have to do. The first one is like defining the objective function, right? Or like deciding resource allocation, like decide what is important. Because the agent can come back and the agent can say, if the goal is X, then this is what we should do. If the goal is Y, this is what we should do. If the goal is Z, this is what we should do. You still have to decide what the goal is, okay? And you have to decide that by understanding all the various trade-offs. And that's really hard to outsource, actually, right? So that's one thing. Also, just like it is much less the case, as we've discussed before, it's like much less the case in science that we are, I expected that it will be much less the case that we're going to like suddenly get super intelligence, right? Because we are limited so much by what is known, right? By what experiments have been run and so on. And so I do think that for some significant amount of time in science, it's going to remain more of like a kind of coworker scenario, whereas maybe in software engineering in 2 or 3 years, like humans are just like not doing it at all.
Can I ask for your opinion on, I would posit that, because we know more about physics and chemistry, we'll see more advances here in automation than in biology, where we know very little.
Oh yeah, and specifically in math, for example, like math within a couple of years should just be completely automated and solved because it's axiomatic, right? Like you don't need to run experiments. You have all the information you need in order to figure things out, right? In physics, you're ultimately bottlenecked at some point by what experiments you can run, right? But also physics is to a large extent like mostly math, right? In biology, you are like very bottlenecked by experiments. And so what the models can do is they can help you to decide what experiments to run, right? Anyone who thinks right now that we are running the best experiments that we could possibly be running has never done biology research before, okay? Right? Like, you know, the way that we allocate resources is definitely not optimal. However, even once we have optimal allocation of resources, the experiments will still take time to run, right?
I really resonate with that. And in general, I just think that every problem has a solution, but every solution creates more problems. And we're going to discover new problems. You guys are solving so many different things in your respective companies. And you know, well, you're going to continue to solve things. None of us are thinking that we're going to work any less because there's just another problem to solve, another problem to solve, another problem to solve.
Thank you guys so much. This has been a great discussion. I do feel an unfortunate sinking sensation where I'm like, I have token anxiety. My throughput is not high enough. I'm going to be asked to do more intellectual labor, but it's okay. It's balanced out by the fact that we're all going to have great software and solve medicine. But you know, it's a mix. It's not a I guess a hang out on the beach mix. Peter, I will ask one last question because I think there's some really interesting announcements and work you've done with NVIDIA. Like, how do you think about the pervasiveness of the adoption of these individual like clause setups? You have, you know, companies in China saying like, come into our shop, we'll set it up for you. Do you imagine that's because of the privacy, because of the tool access, because people want to talk to their computers and their own data? Like, what's the driving factor?
I think it's like, I try to make it fun and weird, and people are curious, and then people try it out, and most haven't really experienced AI in that way. And suddenly you have a friend on Telegram or WhatsApp that can actually do things, you know, that it changes how people think about AI. And I think this is what excites me the most, because in this world where we're like having these rapid changes that are coming upon us, more people need to play with AI. You know, it needs to be something fun and something that I can use to help me, because we're still so early. There's still so much we can learn about how to automate all those things, how we can transform companies. So that's what excites me the most.
Thank you guys for such a wonderful, exciting discussion. We unfortunately have to wrap it up here, but thank you.
Thank you.
Thank you.
Thank you.
I love that the answer to a practical question where I asked about the utility was like, actually, it's great to tinker with. It's really about the claw energy. Let's check back in with Tiffany. Tiff.
Thanks, Sarah. I'm here with Bill McDermott, who is the chairman and CEO of ServiceNow. Bill, the first thing for me that comes to mind when I think about ServiceNow is around agentic AI. And I want to get your take. How have you seen this shift from conversational to agentic AI happen, especially when it comes to enterprises?
Well, Tiffany, first I have to give so much of the credit to Jensen, the one and only Jensen, the GOAT. It's an honor to be here celebrating this like pre-Super Bowl party of technology. So ServiceNow could never have been the company we are without Jensen and without NVIDIA. We started building models together 7 years ago, and we're busy at it, whether it's you know, the GPU factory that's running businesses all over the world are now really moving into inferencing because, as you said, the agents are playing such an important role in running companies. Models are super important and powerful, but they're just expensive advice if you don't put them into action. And that's where the workflow combined with the power of NVIDIA really comes into transforming companies.
Absolutely. The key word is putting them into action. What are some examples of that? Some examples of AI agents that you've really seen either help your own workflow or maybe some stories you've heard?
Yeah, sure. In our company, for example, 90% of the tasks that used to be done by humans in customer service or HR service delivery are now being done by agents. we have prioritized making sure people stay gainfully employed and retraining, retooling, and reskilling them. So they've done even more important work. But no one's denying the power of the autonomous enterprise. Anything that's non-differentiated work will get done by agents, and that's just a fact. So companies have to get in front of it because it's coming really fast. If you look at companies like Rolls-Royce reinventing manufacturing, or, for example, Bell Canada rethinking customer support with agents across their 22 million customer base, it's all now being done by autonomous agents. Adobe, we could talk about so many companies, including the great NVIDIA, the most valuable publicly traded company itself. We're so honored to work with NVIDIA and have our agents busy at work helping them be an even greater company.
Absolutely. And I want to re-emphasize that number. You said 90% internally when it comes to certain tasks. That's incredible.
Yeah.
And I love that you really, with that, as you mentioned, prioritize then upskilling and focusing on different ways individuals can be innovative and what's really coming next.
Yeah, it's so important because if AI isn't in service to people, what good is AI? So we have to really prioritize the impact it's having on people to give people a better life. And it's all possible, but we have to prepare for it, we have to plan for it, and really get busy on it right now. As an example, in our org charts, everybody has an AI agent in their pocket working for them. So whether they're on the move or they're in the office, they have an AI agent. We're now building AI specialists. So you could have an AI specialist, an HR specialist, a security specialist, and they're being orged into the org chart and the fabric of the company itself, not as something to look down upon, but something to really lift us up, make us more productive, help those customers win. And when you do that, your company is going to be thriving, growing, prospering, and creating jobs and opportunities for everyone.
Absolutely, I couldn't agree more. I love the general theme of our conversation is upskilling, using AI to really find the best ways it can be productive for your entire team, for across the entire org.
Sure. Well, in our case, we're pretty lucky. We just believe in NVIDIA and in Jensen, so when they're on a move, whether it was training or inferencing or building the whole factory to reinvent every single data center around the world, we just leaned into that and believed in it. And I believe in him and NVIDIA now more than ever, so I'm just psyched to be a part of this program.
Wow, well, Bill, I think that's a great note to end the conversation on. Thank you for your time.
Thank you.
Stay tuned, we have one more conversation coming up, but first, let's take it back to the stage.
Thank you, Tiffany.
Thank you, Tiffany. And just a reminder to those of you who have tickets to the keynote, you should head inside. You can watch the rest of the pregame, and the arena is filling up.
AI has gotten really good at understanding language and images. Now it's learning how the physical world works. Chatbots had their moment. Now it's physical AI's turn, enabling new possibilities for robotics, autonomous vehicles, intelligent machines, medicine, areas of all kinds. This is AI's breakthrough moment into the real world. And here to discuss how AI enters the physical world, Raquel Erdison, founder and CEO Wabi, Giacomo Corbo, founder and CEO of PhysicsX, Deepak Pathak, founder and CEO, Skilled AI, and Daniel Nadler, founder and CEO, Open Evidence.
Raquel, I love what you're doing. I grew up in New York City, and I don't drive. Well, I've had to learn how to drive coming out here, but my brother still doesn't know how to drive. And you're building autonomous vehicles, and you're doing it not just doing it the brute force way, but you're doing it with simulation as well. Tell us a little bit more about what you're doing at Waabi.
Yeah, so at Waabi, basically we have, we are pioneering technology for verifiable end-to-end systems and simulation first, where you can really build a solution that truly scales, and that where you can actually also prove the safety of the systems that you can deploy in the real world. We started with self-driving trucks, which are really highly performant on the road and doing commercial operations. And we recently announced that we are also entering the robotaxi market with a very different technological approach where a single brain can actually really drive all these different form factors. So it's a pretty exciting time for us.
And what do you see as the frontier problems that you're still solving on autonomy today?
Yeah, so if you look at really what you want is a physical AI platform that can truly generalize, because these are physical AI robots that no matter what happens on the road, really need to work and do the right thing. So what we are really doing now is just scaling the technology, deploying commercially, driverless with our OEM partner, Volvo, which is what you're going to see next, or one of the next things from the company. And really, you will see our beautiful new robotaxis soon. So, we have a partnership with Uber where we are going to deploy a minimum of 25,000 robotaxis. So this is really the next level of scale that you're going to see over the next couple of years.
What, 25,000 across the world in certain areas? What parts of the world?
Yeah, great question. So we haven't unveiled yet what the first market is, but definitely we plan to be a global company. Now we will start with the markets that make sense, right? But yeah, you will see at some point, technology from Waabi, even beyond, I would say self-driving and transportation, which is, thanks to this physical AI platform, a really exciting time to bring robotics everywhere.
Great, thank you.
Giacomo, PhysicsX works with customers in a bunch of different, very real-world domains, from oil and gas to semis companies. When we think about the models we have today that are quite, by nature, approximate, like what's the room for that and our foundation models today and traditional physics-based simulation?
Well, maybe to start with, we're building a new engineering simulation software stack, one that is trying to move the world of a lot of industrials and the engineering, manufacturing, production that happens within these companies to simulation by inference. So, to your point, today, a lot of engineering and being able to predict physics and behavior runs through numerical simulations. They are approximate. We only understand so well the phenomena that are being predicted, and better improving those runs through first principles scientific discovery. But they're also incredibly slow. And so, being able to move that to inference means that, we can do prediction anywhere between 10,000 to close to 1 million times faster. But we can also sort of embed, that very fast prediction into places where you can't do high fidelity simulation. So in control applications, and the rate of improvement now for us to be able to do simulation and, runs through data generation rather than scientific discovery. Like the thing that is sort of powered, whether it's LLMs and agents, everything around robotics as well, and embodiment-free control, is scaling laws. And one of the things that we've established over the course of the last 24 months is scaling laws holding in this domain as well. And that, I think that changes everything for industrials.
That's super exciting. I think something that is not intuitive to folks who work outside of the hard engineering domains is that actually it is a computationally bound field, right? Because I think of AI as being incredibly compute intensive, but it's actually much more efficient and much faster than some of the approaches that actually dominate today.
And it's worse than that. It's because you're generating simulations that can take multiple days. If I want to simulate the combustion inside a large jet engine, it can be 500 hours plus. If I want to be able to now, understand what combustion looks like under leaner conditions, 1% leaner conditions, you can blow that simulation time up by an order of magnitude. And it becomes completely intractable to design things when things are so compute intensive, when they take so long. But what's worse is that there is no such thing really as reuse for numerical simulation data. And one of the things that's changing here is the generation of numerical simulation data to generate the training corpus that I need to be able to bring, to have AI models that understand physics and chemistry at the fidelity required for a lot of these applications. These things can be fine-tuned and steered into new domains and applications, but that paradigm shift of having a training corpus to train models is something that's entirely different from what engineering sits on today.
Genuine curiosity question. Did your customers keep all of those simulation results in reserve, and is it just about accessing them, or did they throw them away?
The cost of storage being non-zero means that that data is systematically purged, yes.
Oh, man. Data being systematically purged. Deepak, some of the things that you've shown us at Skilled, where you can train a new robot that you've never trained on before and make it work and do things that it never was taught to do. Is it really, are robotics, is it generalizing? Are your models generalizing? Is it true that it's generalizing?
Yes. So at Scale, we are building a general purpose brain for robots, which means that any robot, any task, one brain. So as you mentioned, Alfred, this is absurdly general. Just to put in words, the same brain controlling a humanoid in a kitchen environment, the same brain controlling a quadruped dog going around in busy areas, the same brain making a robotic arm cook an egg or omelet. Now, it is generalizing, and as you can see in the results we have released, you can put a new robot, you can either change the shape of the robot by removing limbs, it can adapt on the fly. But the key question is why? Why are we even going so general? Because it's so much beyond even humans. Even humans control only one body. And the reason for that is data. I very much agree in the previous points that data is scarce. In language, vision, speech, we had the luxury of having lots of data and being able to just apply the wave of AI and all these models to the next field, next field, next field. But in robotics, data itself is a problem. And by having this brain so general, we can improve it with data from any kind of robot. No matter, we don't differentiate, we don't distinguish, we are not partial. We can use data from a humanoid acting in a kitchen, even a quadruped going on a road, learning something, helps other robots do new things in the background. And that is the main thesis behind this approach.
And through your approach, are you able to explain how you can rip off a limb and it still adapts? Can you explain how that happens, or is it just the model is just doing it?
So the key idea, the key difference in some ways is, so if you have heard the term in-context learning in language models, right? Now this term in itself is only about 3-4 years old. In the whole history of AI, you would never, and Raquel here has also been a professor, so she would say this term was not existent. We always were training models to be efficient at learning. But turned out, when we made these models learn at big scale, learning efficiently just emerged as a property. So you can learn by showing you a few examples. And that is what is happening here. So these general brain models, it's not like they have learned across every single body ahead of time. They are adapting on the fly. So when you remove a limb or something, what really happens is that new knowledge of history, that I have one less motor to power, goes in the context and it learns from that context. So this idea of in-context learning had only been shown in language or vision where there is ample data, and not outside that field, not even outside language pretty much. This is the first time it is shown in the physical world, and thanks to simulation and other approaches which you can leverage here.
Now some of the models are, in the open source world, they figure out how to distill them pretty cheaply. It's pretty hard to distill a robotics model, from what I understand.
It is pretty hard to distill a robotics model. First, the obvious reason, even the pre-training models don't have as much data. So we are already solving that problem. Second, when you deploy a model on a robot, you over time want that model to become more specialized. And as we are also finding with language models, like if you are using a model for coding, you don't really care at the time how good is it in writing a prose, right? So, but the key is you cannot directly jump for that specialty. Like you have to first go general and then go specialized. Because if you directly go specialized, you will not have enough data and you'll overfit. And that's the same philosophy. So in robotics, we are not really, like you don't have access to the whole original brain. You have access to a distilled version on the device. So it protects against that. But it's also challenging technically, because now you have to fit everything on a device and run in a very fast-paced manner.
Daniel, at Open Evidence, you guys have made the decision to train your own models, to get to specialized models, and then you'll describe it as medical superintelligence. Why do that versus use the general models?
Well, we also use general models, but in medicine, we're talking about physical world intelligence. The ultimate feedback loop from the physical world that we care about as humans is the human body. And I think it's important to distinguish the efforts in medical AI from some of the other efforts in AI. Efforts in coding, for example, are extremely valuable. We use it internally in the company. But if AI generates the wrong line of code, you can delete that, you could try it out, you could see that it's not working, and you can try something else. If AI generates the wrong treatment recommendation, you're going to get a feedback loop from the physical world, from the human body, that you're not so happy to just try again or delete because it's going to hurt a patient, or it's going to, at best, not cure what you're trying to cure. So, like many of my colleagues on this stage, you have to go into the physical world. You have to understand what are the feedback loops that come from the human brain, which is what a neurologist does. What are the feedback loops that come from the human heart, which is what a cardiologist does. And medicine, more than other fields, doesn't need to be explained to what specialization is. In many other fields, this idea in AI of specialized intelligence, specialized agents, and so on, is newer, and it's less intuitive to the people working in the fields. In medicine, they've been specializing since medical school and then beyond. And so this is sort of running with the theme of this panel, which is why I'm on this panel and not on one of the other panels, which is you have to be grounded in the physical world. You have to be grounded in what the physical world dictates and allows. And in the physical world of medicine, in biophysical medicine and the human body, the brain and the heart and all of the other organs only allow so much. So then you have to recreate and mirror the type of specialization in knowledge work that the medical community has already self-organized around. And that's why as we train AI, it's, in our opinion, not going to look like one specialized general intelligence, but many sub-specialized sub-intelligences that collaborate and cooperate together. And each physician in this future is going to have the benefit of a digital twin of a cardiologist, a digital twin of a neurologist, a digital twin of every specialist and subspecialist that they can elastically and dynamically call up to help them on a patient's case.
Yeah, it seems obvious why consumers should want trustworthy medical AI, but I think what you're describing is actually a model of medicine, that is, to me, idealized, which kind of actually looks like the way models work today, right? You have a router, you go to an expert model that is better at this particular task, higher performance. Maybe you can just restate why you think these, clinicians and doctors who did go to medical school and specialize need AI at all, right? They have a bunch of this knowledge themselves.
It's a great question. So I would actually argue that in the 1920s, when the tools of medicine were gauze and scissors, they probably didn't need AI. What's happened in the last 20 or 30 years is this golden age of biotechnology, where we've developed all these tools, these drugs, which are tools for physicians that extend their toolkit beyond the gauze and scissors that you might see in a World War I film. But there are too many of these tools now. If you speak to any physician, they'll say there's 10 to 20,000 FDA-approved drug compounds. They all interact in ways sometimes which are benign, but in other cases which are very harmful to the patient. The combinatorial of 10,000 or let alone 20,000 FDA-approved drug compounds is nearly infinite. Medical school as a vehicle, which is a 4-year program, doesn't allow any more physicians, human physicians, limited by the wet brains that we have in our skulls, to cover the enormous surface area of biomedical knowledge. So it's this sort of tension that, on the one hand, it's this phenomenal accomplishment of the human species that we've developed all these drugs, that there are 2 new biomedical papers being published every minute, 24 hours a day, that there's 40 million biomedical papers published in the world medical literature.
And it's only going to accelerate.
It's accelerating, it's doubling every 5 years, even by the most conservative estimates. By liberal estimates, it's doubling every 73 days. No matter what it is, even if it's every 5 years, they can't just stay in medical school. They can't, even if it were every 5 years, they'd have to just stay in medical school, which is a 4-year program for the rest of their life. That's not feasible. And even people who went to medical school 20 or 30 years ago, they've all had this moment of studying 12 hours a day. They're tired, it's the end of the day, and they wish they could just have a twin. People have had this thought long before Jensen was talking about digital twins, which is why Jensen is so right that the future is digital twins. I think we've all had this thought in grad school, if I could just have a bunch of twins of me that could learn this material,
Grad
I
school
could go
today.
yeah, what's grad school today?
Yeah.
But for those of you who remember what grad school was, we've all had that experience. I wish I could just have a copy of me that could learn this material and know it, who I could sort of elastically call up the next morning when I have the test. Well, that's the experience of physicians. The next morning they have the test. The test is the patient. It's a patient who exists in a body. The body exists in the physical world. You can't just delete the generated line of code that doesn't work. The feedback loop might be catastrophic. So we need to help physicians help patients by giving them digital twins that can help them learn all this material.
Can I follow up, Daniel, on one thing that you've done twice? You've done this twice. This is your second company in AI. This is AI for medicine. Your previous company was Kensho AI for finance. How are you building these 2 companies differently, Open Evidence and Kensho?
Well, one of the gentlemen on the stage here prior was with me at Kensho. So first of all, it's great to see all these Kensho alumni starting their own companies. Harrison
from
Lang Chain and Mikey Schulman at Suno and Martin, come on, all these guys. I think the world has changed so much that it would almost be easier to enumerate the overlap than to enumerate the differences. The overlap involves, there's still a venture capital landscape. You need capital. That kind of is the end of the overlap. Everything is so completely different today.
I've learned nothing.
I've really had to start from scratch all over again. The technology that exists that you can presuppose today as your starting level, I think you're going to, and this is maybe still I don't know if this is a heterodox statement or it's not, but I think you're going to have some of the most valuable companies in the world 10 or 15 years from now have sub 100 employees. And I think the world's not prepared for that. Take Open Evidence. We have sub 100 employees, and 300 million Americans this year are going to be treated by a doctor who used Open Evidence in the loop. So, we're talking about each employee indirectly supporting 6 million patients. I mean, the scale is unfathomable. That's directly a result of what Jensen and NVIDIA and these tools and the people who develop on top of that technology have enabled as the new starting point. And I think the world economy and certainly the tech economy is going to look unrecognizable. You're already seeing it in some of the companies on this stage and some of the companies that were on the previous stage, where you have some of the most impactful companies, certainly some of the most impactful companies in the world have sub 2,000 people, sub 3,000 people, and some of the most impactful companies in the world, including Open Evidence, have sub 100 people supporting 300 million patient interactions with doctors in the United States alone. So that's a new tech economy, that's a new reality, and I've had to learn all that from scratch.
Raquel, you've been working on autonomy for a long time. What lesson is there from how long self-driving is taking and why you think this is the year of scale that we should take to other physical AI domains?
Yeah, and I think self-driving can, is ahead in many ways of some of the other physical AI, domains like humanoids, etc. So I think there is quite a bit to learn. One is that, self-driving started with a roboticist approach, which was, try to build a very overly complex software stack where you basically hand code everything. And one of the things that, one of the reasons I started Wabi 5 years ago was because I didn't believe that was going to get us to a point where scale could ever happen, right? And with a mindset that we should rethink the world with an AI-first approach, right? With a simulation-first approach, which we, I think in this panel we all believe that that's the way where you can really, for physical AI and safety-critical applications, is the only way to really expose the system, test the system to things that otherwise will have tremendous consequences, right? And one of the things that I think will be very important to take from self-driving is how we approach safety, right? Because, as in your domain, consequences of a mistake are actually tremendous, right? So safety cannot be an afterthought. So one of the things that we pioneer is in, can we build simulation systems and even simulation systems that work in the physical world as you drive, like mixed reality testing, augmented reality, where you can really prove for the first time the safety of self-driving systems at this scale. And this new way of doing end-to-end verifiable with reasoning, this way of testing with simulation first, really is going to bring robotics to the next level, and I think that you will see more and more companies in other physical AI applications really adopting that that type of technology.
Is physics X helping us completely shorten the development cycle of things in engineering and taking into account all the safety measures that you need to take? Because if a jet engine explodes, that would not be a good thing.
Yeah, so yes, it wouldn't be a good thing, right? So I think in a whole lot of industrial applications, you can't really tolerate hallucinations. Yeah. We want to be able to build models that can reason and predict physics at the fidelity required for a lot of the applications, whether it's designing things like a jet engine or it's designing a piece of semiconductor manufacturing equipment. But in designing something, we don't have the same, let's say, safety issues. Because what we can do is we can use the AI to be able to explore this huge combinatorial space. We can deploy a whole lot more algorithmic sophistication to how we do that. Now that the simulation step is incredibly fast, but we can then go back to our certified numerical tools in order to be able to validate that we got things right. We can go to a wind tunnel or an engine dyno or the wet lab to be able to validate that things work well. But that's only on the design side. Like the moment that you go into operational control, like deploying AI into a smelter, on a mining site to do copper heap leaching, on a vehicle that is going to do active cooling for the battery itself, or on a piece of semiconductor manufacturing equipment deployed into a fab. In all of those situations, you want to make sure that you understand what the uncertainties are going to be. And there it's a question of having sort of safety guardrails. There are ways to be able to do that. I think that the thing that's incredibly exciting is that we're getting into a paradigm where the same AI that is being used to design the thing is being used across the whole product development lifecycle. So on the manufacturing side, in control applications, and that's different and exciting.
Deepak, everybody wants to know if you look forward, is it next year? Is it the year after? Is it 2030? This is like unimaginable timelines by AI standards. Like when do we actually see robots with more general capability and which applications first?
So I think robotics is the longest existing field of AI and the last one to arrive, right? And there is a reason for it, because it is not like ChatGPT or where you can just build a completely intelligent agent and then have access to millions of people on the first week or day one, right? Here, physical rollout takes time. Physical AI is the biggest market, right? Now, the question is which area? Because will I have a robot in my home this year cooking food for me, cleaning? I mean, that's for sure look like from if you look at the internet. But it would be very weird if you have a humanoid robot in your home this year, which can do all the cooking, all the work for you, and you still don't see robots around you in factories, grocery store, hospitals, and everything else is just done by manual. Even though the numbers say otherwise, there are already million more jobs available than people are able to fill them. So there is a huge demand. In my opinion, the answer is from today all the way to 2030, like whatever year you put in. But the area of application will differ. So today, I cannot reveal details, but we have a big announcement coming that we are going to do big deployments in enterprise in one shot, by partnering with the key players. This is where you start. Enterprise, because over there you actually have people who would pay for a robot, will not sue you if something goes wrong. And you can use that data to go to a bit more unstructured, let's say hospitals, grocery stores. And then you use that data to go even more unstructured, like homes. You solve problem where you increase complexity of the generality over time, and you use the data from the previous iteration for the next iteration. This is what we call a data flywheel. Now, data flywheel is the reason self-driving is even possible today. Our goal is to establish data flywheel step by step, and not just jump to the last thing. So some people will get robots in homes, but the mass adoption will happen when you begin seeing robots around you everywhere else in unstructured areas.
Sounds like a really fun future. Thank you guys for taking AI to the physical world. I can't wait for all of the problems to be solved in the physical world.
Jensen's keynote is coming right up. For those of you who are still hanging out with us in Arena Green, all are welcome to join us inside, so make your way into the keynote now.
Tiffany has been out and about meeting with some of our guests. Tiffany, how's it going out there?
It's going great. Thanks, Alfred. I am here with Alex Kendall, who is the co-founder and CEO of Wave. Alex, autonomous driving is really on everyone's minds. It's the buzz around here, which is so exciting. I think another thing that coincides with that is around the safety when it comes to AI and operating in the real world. How do you think about that?
Well, isn't it fantastic to see the automotive industry really galvanizing around end-to-end AI for autonomous driving? When we pioneered this work a decade ago, this was quite a contrarian idea. But what we've seen is recently, there's so many demos now possible showing that this can actually become a feasible product. But we had a demo 5 years ago, and what we've spent the last 5 years is showing how this can be a product at global automotive scale. So we've now done zero-shot testing in over 500 cities through Europe, Asia, and North America, and we've shown how we can build a world model that can really understand the risk and anticipate the busy dynamics of the roads that we live in. So this means that we're now in a position to not just show demos, but bring embodied AI into consumer products and robotaxis at a truly world scale.
Absolutely. And you mentioned, you look back, 5 years to where you are today. It's incredible the speed which you are moving. I want to look ahead a little bit. What does the next decade look like as AI enters the physical world?
Oh, look, every vehicle is going to be autonomous in the future, and I think automotive is going to be the first large-scale demonstration of embodied AI. But of course, it's just the beginning. But we're really excited to see some major steps forward this year. Of course, we're partnering with great companies like Uber, Stellantis, Mercedes, and of course, Nissan, where this week we're unveiling a new robotaxi. It's on here display at GTC. We announced that we're going to be launching it and bringing it into trials in over 10 cities around the world with Uber. So we're really excited to launch that and see our AI come into consumer vehicles and robotaxis at scale very soon.
That is so exciting. And you mentioned it's on display this week.
Yeah, come take a ride. I took a ride as a lot of guests here at the event this week, where they can ride in our robotaxi and consumer vehicles, experience autonomy. It's really designed to be natural, human-like. So it drives with the hardware that's already built into millions of vehicles today. So no bespoke hardware or retrofit. It can work with the existing vehicle's hardware that's being produced at millions of scale volume and doesn't need a high definition map. So it doesn't need to drive in a pre-mapped area, but can truly drive at a global scale. We're the only company now to drive zero shot in over 500 cities. And we've seen the system drive all around the world. It's quite remarkable. Please go have a drive.
I definitely am going to need to do that. That's incredible. And you said you're repeat that again, that stat at the end you said. You're the only company, finish that sentence,
To have driven zero shot. I mean, AI driving in safety is all about the ability to generalize. And driving zero shot means driving somewhere where you've never had training data from that location before. And this is really important because the world's too large to collect data from every single experience. So you need to be able to learn general purpose behaviors. And that's exactly what we've developed with our world model. The ability to anticipate risk, understand the dynamic and unexpected movement of people all around the world, and to take this behavior and generalize it to new scenes, to new vehicles, to new countries, cities, weather. That's the core problem of embodied AI and what we've been able to show.
Wow, that's truly incredible. I am so excited for this ride. You will definitely see me taking one. Alex, thank you so much for your time.
Awesome, thank you.
So we have covered a lot today, a lot of different technologies from agentic AI, physical AI. I mean, we even spoke about energy and everything in between. It is truly an exciting time. Now, if you're not in your seat already, you better get there quickly because the keynote is about to start. Thank you so much for following along today, joining these conversations with me. I mean, I don't know about you, but they were so inspiring, so much fun. Now, before we go, I'm going to throw it back to the stage.
Thanks, Tiff. Great work out there.
So that's a wrap for the pregame.
In just moments, NVIDIA CEO Jensen Huang will take the stage with his vision for how NVIDIA is building the future we've been all talking about on the stage.
We'd like to thank our many incredible guests, top AI leaders who are bringing about the next industrial revolution. I also want to thank my co-hosts, Gavin Baker and Alfred Lin, Tiffany Jansen, and the entire NVIDIA team for an unforgettable morning of insights and inspiring ideas.
Thank you, Sarah. Our day's not done yet. Hopefully, they save some seats for us because we're going to have to run over there for Jensen's keynote. I wouldn't want to miss it.
Me neither. From the SAP Center in San Jose, California, thanks for watching.
Bye.
Let it ring like a hotline. Up for the night, living life for the plot line. You a good melody, I got a top line. You number one, make them settle for the top line. Cause you always in the bag, pop another tag. Quality is everything, cause moments never
Same old train, same tire, playlist thinking, is this all I'm worth? Getting in the night lights up my screen, sent the text that flips my bay. Keep your eyes wide open, now I can't look away. You're gonna say something amazing today, like the first blue sky after weeks of play. Doesn't look special till it suddenly changes. Hold your breath, heart beat, everything rearranges. You're gonna see something amazing today. Elevator up, heartbeat high, city home like a quiet prayer. You walk in, laughing at nothing, suddenly there's color in the air. Every small step feels like fireworks, every shy glint feels brand new. Didn't think the world could flip this fast, but it did when I saw. You're gonna see something amazing today, like the first blue sky after weeks of gray. Doesn't look special till it suddenly changes. Hold your breath, heartbeat, anything rearranges. You're gonna see something amazing today. Maybe it's a stranger saying hi, maybe it's a tear you let fall this time, maybe it's just you finally believing you. You're gonna see something amazing today, like the first blue sky after weeks of rain. Gotta look special till it suddenly changes. Hold your breath, heartbeat, everything rearranges. You're gonna see something amazing. You're gonna be something amazing today.
Dust on my boots and a full tank, sun burning low in the rear view glass. You laughed, said, boy, this is your big plan. I smiled, said, girl, that's the first half. We ain't even hit that gravel, we ain't even killed that light. If you think this is a party, stick around tonight. You ain't seen nothing yet, we're just getting started, babe. Got a back road, got a sunset, got your hand in mine and a wild heart set. On every mile, every kiss, every red Corvette in my head. Baby, this is just the first step. You ain't seen nothing yet, you ain't seen nothing yet. Cooler in the bed, old shirts for a blanket. That song you love on the dash lit blue. You said this feels like the ending. I said, no, this is the preview. We ain't even hit that river, we ain't even lost that phone. If you think you know my favorite, wait till I make you my home. You ain't seen nothing yet, we're just getting started, babe. Got a back road, got a sunset, got your name in mine on a mailbox sketch. Every bow, every fight, every makeup breath in our bed. boots by the front door, tiny jersey with my last name. If you think this love is crazy, you ain't read the back half of this page. You ain't seen nothing yet, we're just getting started, babe. From the backseat to the front porch, to a crowded church and a white dress. Every year, every tear, every sweet silhouette in that dress. Baby, this is just the first step. You ain't seen nothing yet. You ain't seen nothing yet. You ain't seen nothing
I've been counted out, left on red, left in doubt. Every maybe felt like never, but I kept your picture in my wallet. Folded corners, yeah, I saw it. Every time the world said whatever, I get that tightness in my chest. When the floor drops, I don't rest. I just breathe, then move step by step. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands stop bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying. Never gonna stop trying. Friends turned strangers overnight. Dreams went quiet, lost their light, but I learned to glow in the shadow. Talk to mirrors like a coach, get back up, that's all she wrote. So I run through every high, every hollow, and it's in my chest. But this fight don't accept any ending that says regret. Not yet. I'm never gonna stop trying, even when the waves keep rising. my side like a choir for my life, singing one more time, one more time. Hey! I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands stop bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying.
Keep on checking, mine runs wild. Every scene projecting, got your name doodled on my playlist. If this is wrong, I kinda wanna stay missed. I can't wait to see this play out in real life. Us in the front row, laughing through the late nights. I can't wait to feel it. First love, first kiss, whatever this becomes. I can't wait to see this. What
something shift. Same room, but the air felt thick. Mirror said I'm still that kid. Art said you're bigger than this. Tie my laces, hands still shook. First step was the hardest one. Every lap, every sideways look, all fade when the race is run. I carried every doubt lightweight. Now I'm lighter than the flame. You can write it on the page. Everything changed. A legend was made today. From every little scar, every heartbreak, took all of the nights I almost walked away, and I turned them into gold in the name. Remember this face, this place, when the crowd stands up and they all say, a legend was made today. A legend was made today. Oh yeah. Hands up when I cross that line. Flashbulbs in my open eyes. But the loudest thing I heard was my own voice saying rise. All the times I came up short, played them back like old home tapes. Now they're just the proof I've grown. Steps I took to reach this day. I carried every doubt lightweight. Now I'm lighter than the flame. You can write it on the page. Everything changed. A legend was made today. From every little scar, every heartbreak, took all of the nights I almost walked away, and I turned them into gold into my name. Remember this face, this place, when the crowd stands up and they all say, a legend was made today. A legend was made today. This is for the kid who writes, for the one who's tired of trying. If you're standing on that edge, let this moment be your sign. A legend was made today. A legend was made today. From every little scar, every heartbreak, took all of the nights I almost walked away, and I turned them into gold in my name. You remember this face, this place, when the crowd stands up and they all say, a legend was made today. A legend was made today. A legend was made today.
Yeah. You feel that? All right. Things. Everybody looking for a new thing. There you go, moonwalking like two wings. Just flew in, put the room in the mood ring. You got ring like a hotline. Up for the night, living life for the plot line. You a good melody, I got a top line. You number one, make them settle for the top nine. Cause you always in the bag, pop another tag. Quality is everything, cause moments never last. I don't wanna know how many minutes do we have till it's midnight. High heels click like glass on the floor. I heard people
Phone screen girl on my face, coffee stain on my plain white shirt. Same old chain, same tie, playlist thinking, is this all I'm worth? And then it lights up my screen, sent the text that flips my bay. Keep your eyes wide open, now I can't look away. You're gonna see something amazing today, like the first blue sky after weeks of play. Doesn't look special till it suddenly changes. Hold your breath, heart beat, everything rearranges. You're gonna see something amazing today. Elevator up, heartbeat high, city home like a quiet prayer. You walk in, laughing at nothing. Suddenly there's color in the air. Every small step feels like fireworks. Every shy glance feels brand new. Didn't think the world could flip this fast, but it did when I saw. You're gonna see something amazing today, like the first blue sky after weeks of gray. Doesn't look special till it suddenly changes. Hold your breath, heart beat, anything rearranges. You're gonna see something amazing today. Maybe it's a stranger saying hi. Maybe it's a tear you let fall this time. Maybe it's just you finally believing you're gonna see something amazing today, like the first blue sky after weeks of gray. Gotta look special till it suddenly changes. Hold your breath, heart beat, everything rearranges. You're gonna see something amazing. You're gonna be something amazing today.
Good job.
Dust on my boots and a full tank, sun burning low in the rear view glass. You laughed, said, boy, this is your big plan. I smiled, said, girl, that's the first half. We ain't even hit that gravel, we ain't even killed that light. If you think this is a party, stick around tonight. You ain't seen nothing yet, we're just getting started, babe. Got a back road, got a sunset, got your hand in mine, and a wild heart set. On every mile, every kiss, every red Corvette in my head, baby, this is just the first step. You ain't seen nothing yet, you ain't seen nothing yet. Cooler in the bed, old shirts for a blanket, that song you love on the dash lit blue. You said this feels like the ending, I said no, this is the preview. We ain't even hit that river, by the front door, tiny jersey with my last name. If you think this love is crazy, you ain't read the back half of this page. You ain't seen nothing yet, we're just getting started, babe. From the backseat to the front porch, to a crowded church and a white dress. Every year, every tear, every sweet silhouette in that dress. Baby, this is just the first step. You ain't seen nothing yet. You ain't seen nothing yet. You ain't seen nothing
I've been counted out, left on red, left in doubt. Every maybe felt like never, but I kept your picture in my wallet. Folded corners, yeah, I saw it. Every time the world said whatever, I get that tightness in my chest. When the floor drops, I don't rest. I just breathe, then move step by step. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands stop bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying. Never gonna stop trying. Friends turned strangers overnight. Dreams went quiet, lost their light, but I learned to glow in the shadow. Talk to mirrors like a coach, get back up, that's all she wrote. So I run through every high, every hollow, and it's in my chest. But this fight don't accept any ending that says regret. Not yet. I'm never gonna stop trying, even when the waves keep rising.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge and drawing on all we have learned. Tokens are harnessing a new wave of clean energy. And unlocking the secrets of the stars. In virtual worlds, they help robots learn. And in the physical world, perfect. Forging new paths. And clearing the way for a bountiful harvest. In the moments that matter, tokens are already there. And in the miles between, they never stop. They work where human hands cannot. So we may all breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground. On a scale never attempted to empower the world. So we can reach
Star Cloud 1, separation confirmed.
Well beyond it. Together, we take the next great leap into a bright new future built for all mankind. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC! I just want to remind you, this is a tech conference. All these people lining up so early in the morning, all of you in here, it's great to see you. GTC. GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDA-X. Our systems is another platform. And now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. But before I start, let me thank our pre-game show hosts. I thought they did a great job. Sarah Go of Conviction. Alfred Lim, Sequoia Capital, NVIDIA's first venture capitalist. Gavin Baker, NVIDIA's first major institutional investor. These 3 people are deep in technology, deep in what's going on, and of course, they have just a really broad reach of technology ecosystem. And then, of course, all of the VIPs that I hand-selected to join us today, all-star team. I want to thank all of you for that. I also want to thank all the companies that are here. NVIDIA, as you know, is a platform company. We have technology, we have our platforms, we have rich ecosystem. And today, there are probably 100% of the $100 trillion of industry here. 450 companies sponsored this event. I want to thank you. 1,000 technical sessions, 2,000 speakers. This conference is going to cover every single layer of the 5-layer cake of artificial intelligence, from land, power, and shell, the infrastructure, to chips, to the platforms, the models, and of course, the most important, and ultimately, what's going to get this industry taken off is all of the applications. But it all began here. This is the 20th anniversary of CUDA. We've been working on CUDA for 20 years. For 20 years, we've been dedicated to this architecture, this revolutionary invention, SIMT, single instruction, multi-threaded, writing scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could help people program tensor cores and the structures of mathematics that are so foundational to artificial intelligence today. Thousands of tools and compilers and frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud. We're in every computer company. We serve just about every single industry. The installed base of CUDA is the reason why the flywheel is accelerating. The installed base is what attracts developers, who then creates new algorithms that achieves a breakthrough. For example, deep learning. There are so many others. Those breakthroughs leads to entirely new markets, which builds new ecosystems around them with other companies that join, which creates a larger installed base. This flywheel is now accelerating. The number of downloads of NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever. This flywheel is what makes this computing platform able to sustain so much applications, so many new breakthroughs, but most importantly, it also enables these infrastructures to have extraordinarily useful life. And the reason for that is very obvious. There's so many applications that you can run on NVIDIA CUDA. We support every single phase of the AI lifecycle. We address every single data processing platform. We accelerate scientific principled solvers of all different kinds. And so the application reach is so great that once you install NVIDIA GPUs, the useful life of it is incredibly high. It is also one of the reasons why Ampere, that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high, the developer reach is great. And when all of that happens, and we continuously update our software, the computing cost declines. The combination of accelerated computing, speeding up applications tremendously. Meanwhile, as we continue to nurture and continue to update software over its life, not only do you get the first-time pop, you get the continuous cost reduction of accelerated computing over time. And we're willing to nurture, willing to support every single one of these GPUs in the world because they're all architecturally compatible. We're willing to do so because the install base is so large, if we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down computing cost, which ultimately encourages new growth. So CUDA is at the center of it. But our journey to CUDA actually started 25 years ago. GeForce I know how many of you grew up with GeForce. GeForce is NVIDIA's greatest marketing campaign. We attract future customers starting long before you could afford to pay for it yourself. Your parents paid. Your parents paid. Your parents paid for you to be NVIDIA customers. And every single year, they paid up year after year after year until someday you became an amazing computer scientist and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader, a perfectly unobvious invention to make an accelerator programmable, the world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore further and further. 20 years later, 5 years later, the invention of CUDA. One of the biggest investments that we made, and we couldn't afford it at the time, and it consumed the vast majority of our company's profits, was to take CUDA on the backs of GeForce to every single computer. We dedicated ourselves to create this platform because we felt so strongly about its potential. But ultimately, the company's dedication to it, despite the hardships in the beginning, believing in every single day, for 13 generations of 20 years, we now have CUDA installed everywhere. The pixel shader led to, of course, the revolution of GeForce. And then 10 years ago, we introduced, about 10 years ago, 8 years ago, we introduced RTX, a complete redesign of our architecture for the modern era of computer graphics. GeForce brought CUDA to the world. GeForce, therefore, enabled Alex Krizhevsky and Alias Sutskever and Jeff Hinton, Andrew Ng, and so many others to discover that the GPU could be their friend in accelerating deep learning. It started the big bang of AI. 10 years ago, we decided that we would fuse programmable shading and introduce two new ideas: ray tracing, hardware ray tracing, which is incredibly hard to do, and a new idea at the time. Imagine, about 10 years ago, we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done all together. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it. Is that incredible? Computer graphics comes to life Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combine 3D graphics, structured data, with generative AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these two ideas, controlled through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of trustworthy AI. Well, this is going to scare you a little bit. I'm going to flip the slide, and don't gasp. So we're going to go through this schematic for the rest of the time. This is my best slide. Every time I ask the team, what's my best slide? Repeatedly, this was it. They say, don't do it, Jensen, don't do it. I said, no, these seats are free for some of you. So this is your price of admission. So this is structured data. You've heard of it, SQL, Spark, Pandas, Velox, some of these really, really important, very large platforms, Snowflake, Databricks, EMR, Amazon EMR, Azure Fabric, Google Cloud, BigQuery. All of these platforms are processing data frames. These data frames are giant spreadsheets, and they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data, and we better accelerate the living daylights out of it. It used to be okay, and we would, of course, we would accelerate structured data so that we could do more, we could do it more cheaply, we could do it more frequently per day, and keep the company running at a much more synchronized way. However, in the future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much, much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches, all of the world's information, about 90% of what's generated every single year is unstructured data. Until now, this data has been completely useless to the world. We read it, we put it into our file system, and that's it. Unfortunately, we can't query it. We can't search for it. It's hard to do that. And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multi-modality perception and understanding, to go read a PDF, to understand its meaning. And from that meaning, embed it into a larger structure that we can search into, we can query into. NVIDIA created two foundational libraries, just like we created RTX for 3D graphics. We created cuDF for data frames, structured data. We created cuVS for vector stores, semantic data, unstructured data, AI data. These two platforms are going to be two of the most important platforms in the future. Super excited to see its adoption throughout the network, this complicated network of the world's data processing systems. And the reason for that is because data processing has been around a long time. And therefore, so many different companies and platforms and services, it has taken us a long time to integrate deeply into this ecosystem. I'm super proud of the work that we're doing here. And then today, we're announcing several of them. IBM, the inventor of SQL, one of the most important domain-specific languages of all time, is accelerating Watson X data with cuDF. Let's take a look at it. NVIDIA accelerates data processing in the cloud. We also accelerate data processing on-prem. As you know, Dell is the world-leading computer systems maker, and they also are one of the world's leading storage providers. And they worked with us to create the Dell AI data platform that integrates cuDF and cuVS to create an accelerated data platform, well, for the era of AI. And this is an example of what they did with NTT Data, huge speed up. This is cloud, Google Cloud, and Google Cloud, as you know, we've been working with Google Cloud for a very long time. We accelerate Google's Vertex AI. We now accelerate BigQuery, really important framework and really important platform. And this is an example of our work together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate data processing, when you accelerate computing, you get the benefit of speed, you get the benefit of scale, but most importantly, you also get the benefit of cost. And so all of those come together as one. It was originally called Moore's Law. Moore's Law was about getting performance doubling every couple of years. It's another way of saying, so long as the price remains about the same, and most computers remained about the same, you're also getting twice the performance every year, or you're reducing the cost of computing every single year. Well, Moore's Law has run out of steam. We need a new approach. Accelerated computing allows us to take these giant leaps forward. And as you will see later, because we continue to optimize the algorithms, and NVIDIA is an algorithm company, as we continue to optimize the algorithms, and because our reach is so large and our install base is so large, we can reduce the computing cost, increasing the scale, increasing the speed for everybody continuously. This is Google Cloud. You could see this pattern I just mentioned. I just wanted to show you 3 versions of it. NVIDIA built the accelerated computing platform. Has a bunch of libraries on top. I gave you 3 examples. RTX is one of them, cuDF is another, cuVS, and we'll show you a few more. These libraries sit on top of our platform. But ultimately, we integrate into the world's cloud services, into the world's OEMs, and together, and other platforms that I'll show you, together, we're able to reach the world. This pattern, NVIDIA, Google Cloud, Snapchat, will repeat over and over again, and it kind of looks like this. And so this is one example, NVIDIA with Google Cloud. We accelerate Vertex AI. We accelerate BigQuery. I'm super proud of the work that we've done with JAX and XLA. We're incredible on PyTorch. We're the only accelerator in the world that's incredible on PyTorch and incredible on JAX and XLA. And the customers that we support, the Base 10s, the CrowdStrikes, Puma, Salesforce. They're not our customers, but they're customers, developers of ours that we've integrated the NVIDIA technologies into that we can then land on the clouds. Our relationship with cloud service providers are essentially us bringing customers to them. We integrate our libraries, we accelerate workloads, and we land those customers in the clouds. And so, as you could see, most of our cloud service providers love working with us, and they're always asking us to land the next customer on their cloud. And I just want to let you know, there are a lot of customers. We're going to accelerate everybody. And so there'll be lots and lots of customers we'll be able to land in your cloud. Just be patient with us. And so this is Google Cloud. This is AWS. We've been working with AWS a long time. And one of the things I'm super excited about this year is we're going to bring OpenAI to AWS. And so it's going to drive enormous consumption of cloud computing at AWS. It's going to expand the reach and expand the compute of OpenAI. And as you know, they are completely compute constrained. And so AWS, we accelerate EMR, we accelerate SageMaker, we accelerate Bedrock. NVIDIA's integrated really deeply into AWS. They were our first cloud partner. Microsoft Azure. NVIDIA's A100 supercomputer was the first one we built was for NVIDIA. The first one we installed was at Azure. And that led to the big successful partnership with OpenAI. But we've been working with Azure for quite a long time. We accelerate Azure Cloud. Now it's their AI Foundry we partner deeply with. We accelerate Bing Search. We work with them on Azure regions. This is one of the areas that is incredibly important as we continue to expand AI throughout the world. One of the capabilities that we offer is confidential computing. That in confidential computing, you want to make sure that even the operator cannot see your data. Even the operator cannot touch or see your models. Confidential computing, NVIDIA's GPUs is the first ones in the world to do that. It's now able to support confidential computing and protected deployment of these very valuable OpenAI models and Anthropic models throughout clouds and different regions, and all because of our confidential computing. Confidential computing is super important. And here's an example where we have different customers that we work with. Synopsys, a great partner of ours, we're accelerating all of their EDA and CAE workflows. And then we landed at Microsoft Azure. We were Oracle's first AI customer. Most people would have thought we were their first supplier. We were their first supplier also, but we were their first AI customer. I'm quite proud of the fact that I explained AI clouds to Oracle for the first time, and we were their first customer. Since then, they've really taken off. We've landed a whole bunch of our partners there, Cohere and Fireworks, and of course, very famously, OpenAI. A great partnership with CoreWeave. They're the world's first AI native cloud, a company that was built with only one singular purpose: to provision, to host GPUs as the era of accelerated computing showed up, and to host for AI clouds. They've got some fantastic customers, and they're growing incredibly. One of the platforms that I'm quite excited about is Palantir and Dell. The three of our companies have made it possible to stand up a brand new type of AI platform, the Palantir Ontology platform, an AI platform. And we could stand up these platforms in any country, in any air-gapped region, completely on-prem, completely on-site, completely in the field. AI could be deployed literally everywhere. Without our confidential computing capability, without our ability to build the end-to-end system, as well as offer the entire accelerated computing and AI stack, from data processing, whether it's vectors or structures, all the way to AI, it wouldn't have been possible. I wanted to show you these examples. This is our special working relationship with the world's cloud service providers. And all of them are here. And I get the benefit of seeing them during booth tour, and it's just so incredibly exciting. I just want to thank all of you for the hard work. What NVIDIA has done is this. And you're going to see this theme over and over again. NVIDIA is vertically integrated, the world's first vertically integrated but horizontally open company. And the reason that's necessary is very simple. Accelerated computing is not a chip problem. Accelerated computing is not a systems problem. Accelerated computing has a missing word. We just never say it anymore. Application acceleration. If I could make a computer run everything faster, that's called a CPU. But that's run out of steam. The only way for us to accelerate applications going forward and continue to bring tremendous speed up, tremendous cost reduction, is through application or domain-specific acceleration. I dropped that phrase in the front, and therefore it just became accelerated computing. And that is the reason why NVIDIA has to be library after library, domain after domain, vertical after vertical. We are a vertically integrated computing company. There is no other way. We have to understand the applications, we have to understand the domain, we have to understand fundamentally the algorithms, and we have to figure out how to deploy the algorithm in whatever scenario it wants to be deployed, whether it's a data center, cloud, on-prem, at the edge, or in a robotic system. All of those computing systems are different. And finally, the systems and chips. We are vertically integrated. What makes it incredibly powerful, and the reason why you saw all the slides, is because NVIDIA is horizontally open. We'll work and integrate NVIDIA's technology into whatever platform you would like us to integrate into. We offer you the software, we offer you libraries, we integrate with your technology so that we can bring accelerated computing to everybody in the world. Well, this GTC is really a great demonstration of that. You know, most of the time you'll see me talk about these verticals, and I'll use some examples. But in every single case, whether it's automotive, by the way, financial services, the largest percentage of attendees at this GTC is from the financial services industry. I know, I'm hoping it's developers, not traders. Guys. Here's one thing I wanted to say. And so, in the audience represents NVIDIA's ecosystem upstream of our supply chain and downstream of our supply chain. And we think about our supply chain upstream and downstream. And it's just so exciting that our entire upstream supply chain this last year, irrespective of whether you're a 50-year-old company, we have 70-year-old companies, we have a 150-year-old company who are now part of NVIDIA's supply chain and partnering with us either upstream or downstream. And last year, you had your record year. Did you not? Congratulations. We're on to something here. This is the beginning of something very, very big. And so, if you look at accelerated computing, we've now set the computing platform, but in order for us to activate those computing platforms, we need to have domain-specific libraries that solve very important problems in each one of the verticals that we address. You see us addressing every single one of this. Autonomous vehicles, our reach, our breadth, our impact, incredible. We have a track on that. Financial services, I just mentioned. Algorithmic trading is going from classical machine learning with human featured engineering called the quants did that, to now supercomputers studying massive amounts of data, discovering insight and discovering patterns by itself. And so this is going through its deep learning and its transformer moment. Healthcare is going through their ChatGPT moment. Some really exciting work that we're there. We have a great keynote track here. We have a great keynote track. Kimberly Powell's doing a great keynote track for healthcare. We're talking about AI physics or AI biology for drug discovery, AI agents for customer service and support of diagnosis, and of course, physical AI, robotic systems. All these different vectors of AI have different platforms that NVIDIA provides. Industrial, we are completely resetting and starting the largest build-out of human history. And most of the world's industries, building AI factories, building chip plants, building computer plants, are represented here today. Media and entertainment, gaming, of course, real-time AI platform so that we could translation and broadcast support and live games and live video. Enormous amount of it will be augmented with AI. We have a platform called Holoscan. Quantum, there are 35 different companies here building with us the next generation of quantum GPU hybrid systems. Retail and CPG, using NVIDIA for supply chain, creating agentic shopping systems, AI agents for customer support. A lot of work being done here. $35 trillion industry. Robotics, $50 trillion industry in manufacturing. NVIDIA's been working in this area for a decade now, building 3 computers, the fundamental computers necessary to build robotic systems. We are integrated with, working with literally every single company that we know of building robots. We have 110 robots here at the show. And then telecommunications. About as large as the world's IT industry, about $2 trillion. We see, of course, base stations everywhere. It's one of the world's infrastructures. It was the infrastructure of the last generation of computing. That infrastructure is going to get completely reinvented. And the reason for that is very simple. That base station, it does one thing, which is base station, is going to be an AI infrastructure platform in the future. AI will run at the edge. And so lots of great discussion there. And our platform there is called Ariel, our AI RAN. Big partnership with Nokia, big partnership with T-Mobile and many others. At the core of our business, everything that I just mentioned, computing platforms, but very importantly, our CUDA-X libraries. Our CUDA-X libraries is the algorithms that NVIDIA invents. We are an algorithm company. That's what makes us special. That's what makes it possible for me to be able to go into every single one of these industries, imagine the future, and have the world's best computer scientists describe and solve problems, refactor it, re-express it, and turn it into a library. We have so many. I think we have, at this show, we're announcing 100 libraries, 70 libraries, maybe 40 models. And that's just at the show. We're updating these all the time. We're updating them all the time. The libraries is the crown jewels of our company. It is what makes it possible for that platform, the computing platform, to be activated in service of solving a problem, making impact. One of the most important libraries that we ever created, cuDNN. CUDA Deep Neural Networks. It completely revolutionized artificial intelligence, caused the big bang of modern AI. Let me show you a short video about CUDA-X. Everything you saw was a simulation. Some of it was principle solvers, fundamental physics solvers. Some of it was AI surrogates, AI physical models. And some of it was physical AI robotics models. Everything was simulated. Nothing was animated. Nothing was articulated. Everything was completely simulated. That is what fundamentally NVIDIA does. It is through the connection of understanding of the algorithms with our computing platforms that we're able to open up to unlock these opportunities. NVIDIA is a vertically integrated computing company with open horizontal integration with the world. So that's CUDA-X. Well, just now you saw a whole bunch of companies. You saw Walmart and there's L'Oreal and incredible companies, established companies, JP Morgan and Roche. And these are companies that have defined society to today. Toyota is here. These are some of the largest companies in the world. It is also true that there's a whole bunch of companies you've never heard of. These are companies, we call them AI natives. A whole bunch of small companies. The list is gigantic. I couldn't, this is just a little tiny bit of it. And I couldn't decide whether to show you more or show you less. And so I made it so that you couldn't see any. And nobody's feelings are hurt. However, inside this list are a bunch of brand new companies. They're companies like, for example, you might have heard a couple of them, OpenAI, Anthropic, but there's a whole bunch of others. There's a whole bunch of others, and they serve different verticals. Something happened in the last 2 years, particularly this last year. We've been working with the AI natives for a long time, and this last year, it just skyrocketed. I'll explain to you why it happened. This industry has skyrocketed. $150 billion of investment into venture investment into startups, the largest in human history. This is also the first time that the scale of the investments went from millions of dollars, tens of millions of dollars, to hundreds of millions of dollars and billions of dollars. And the reason for that is this is the first time in history that every single one of these companies needs compute, and lots of it. They need tokens, lots and lots of it. They're either going to create and build and create tokens and generate tokens, or they're going to integrate, add value to tokens that are available, created by Anthropic and OpenAI and others. And so this industry is different in so many different ways, but the one thing that is very clear, the impact that they're making, the incredible value that they're delivering already is quite tangible. AI natives, all because we reinvented computing. Just like during the PC revolution, a whole bunch of new companies were created, just as during the internet revolution, a whole bunch of companies were created, and the mobile cloud, a whole bunch of companies were created. Each one of them had their own standards, and we're talking about one of the major standards that just happened, incredibly important. And this generation, we also have our own large number of very, very special companies. We reinvented computing. It stands to reason there's going to be a whole new crop of really important companies, consequential companies for the future of the world. The Googles, the Amazons, the Metas, consequential companies that have come as a result of the last computing platform shift. We are now at the beginning of a new platform shift. But what happened in the last couple of years? Well, we've been watching, as you know, we've been working on deep learning and working on AI. The big bang of modern AI, we were right there at the spot, and we've been advancing this field for quite some time. But why the last 2 years? What happened in the last 2 years? Well, three things. ChatGPT, of course, started the generative AI era. It's able to not just understand, perceive and understand, it's able to also translate and generation of unique content. I showed you the fusion of generative AI with computer graphics, and it brought computer graphics to life. You guys, everybody in the world should be using ChatGPT. I know I use it every single morning, used it plenty this morning. And so ChatGPT was the generative AI era. The second, by the way, generative computing, versus the way we used to do computing. It's generative AI is a capability of software, but it has profoundly changed how computing is done. Computing used to be retrieval-based, now it's generative. Keep that thought in mind when I talk about certain things, and you'll realize why it is that everything that we do is going to change how computers are architected, how computers are provided, how computers are going to be built out, and what is the meaning of computing altogether. Generative AI, 2023, end of 22, 2023. The next, reasoning AI, 01, and then took off with 03. Reasoning allowed it to reflect, allows it to think to itself, allowed it to plan, break down problems, and decompose a problem it couldn't understand into steps or parts that it could understand. It could ground itself on research. 01 made generative AI trustworthy and grounded on truth. That caused ChatGPT to simply took off. And that was a very, very big moment. The amount of input tokens that was necessary in order to produce and the amount of output tokens it generated in order to reason, the model was a little bit larger. Of course, you could have much larger models. The model 01 was a little bit larger, not much larger, but its input token usage for context and its output token for thinking increased the amount of computation tremendously. Then came Claude Code, the first agentic model. It was able to read files, code, compile it, test it, evaluate it, go back and iterate on it. Claude Code has revolutionized software engineering, as all of you know. 100% of NVIDIA is using a combination of, or oftentimes all three of them, Claude Code, Codex, and Cursor, all over NVIDIA. There's not one software engineer today who is not assisted by one or many AI agents helping them code. Claude Code completely revolutionized. It's the new inflection. And for the first time, you don't ask an AI what, where, when, how. You ask it create, do, build. You ask it to use tools, take your context, read files. It's able to agentically break down a problem, reason about it, reflect on it. It's able to solve problems and actually perform tasks. An AI that was able to perceive became an AI that could generate. An AI that could generate became an AI that could reason. An AI that could reason now became an AI that can actually do work. Very productive work. The amount of computation in the last 2 years, we know that everybody in this room knows the computing demand for NVIDIA GPU is off the charts. Spot pricing is skyrocketing. You couldn't find a GPU if you tried, and yet, in the meantime, we're shipping GPUs out. Incredible amounts of it, and demand just keeps on going up. There's a reason for that. This fundamental inflection. Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI now has to think. In order to think, it has to inference. AI now has to do. In order to do, it has to inference. AI has to read. In order to do so, it has to inference. It has to reason. It has to inference. Every part of AI, every time it has to think, it has to reason, it has to do, it has to generate tokens, it has to inference. It's way past training now. It's in the field of inference. So the inference inflection has arrived. At the time when the amount of tokens, the amount of compute necessary increased by roughly 10,000 times. Now, when I combine these two, the fact that since in the last 2 years, the computing demand of the work has gone up by 10,000 times. And the amount of usage has probably gone up by 100 times. People have heard me say, I believe that computing demand has increased by 1 million times in the last 2 years. It is the feeling that we all have. It is the feeling every startup has. It's the feeling that OpenAI has. It's the feeling that Anthropic has. If they could just get more capacity, they could generate more tokens. Their revenues would go up. More people could use it. The more advanced, the smarter the AI could become. We are now at that positive flywheel system. We have reached that moment. The inflection, the inference inflection has arrived. Last year, at this time, I said that where I stood at that moment in time, we saw about $500 billion. We saw $500 billion of very high confidence demand and purchase orders for Blackwell and Rubin through 2026. I said that last year. Now, I don't know if you guys feel the same way, but $500 billion is an enormous amount of revenue. Not one impressed. I know why you're not impressed, because all of you had record years. Well, I'm here to tell you that right now where I stand, a few short months after GTC DC, 1 year after last GTC, right here where I stand, I see through 2027 at least $1 trillion. Now, does it make any sense? And that's what I'm going to spend the rest of the time talking about. In fact, we are going to be short. I am certain computing demand will be much higher than that. And there's a reason for that. So the first thing is, we did a lot of work in the last year. Of course, as you know, 2025 was NVIDIA's year of inference. We wanted to make sure that not only were we good at training and post-training, that we were incredibly good at every single phase of AI, so that the investments that were made, investments made in our infrastructure, could scale out for as long as they would like to use it. And the useful life of NVIDIA's infrastructure would be long, and therefore the cost would be incredibly low. The longer you could use it, the lower the cost. There's no question in my mind. NVIDIA systems are the lowest cost infrastructure you could get for AI infrastructure in the world. And so the first part was, last year was all about AI for inference, and it drove this inflection point. Simultaneously, we were very pleased last year that Anthropic has come to NVIDIA, that MSL, Meta SL, has chosen NVIDIA. And meanwhile, and as a collection, as a group, this represents 1/3 of the world's AI compute, open source models. Open source models have reached near the frontier, and it is literally everywhere. And NVIDIA, as you know, today, we're the only platform in the world today that runs every single domain of AI across every single one of these AI models, in language and biology, in computer graphics, computer vision, in speech, proteins and chemicals, robotics and otherwise, edge or cloud, any language. NVIDIA's architecture is fungible for all of that, and we're incredible for all of that. That allows us to be the lowest cost, the highest confidence platform. Because when you're building these systems, as I mentioned, $1 trillion is an enormous amount of infrastructure. You have to have complete confidence that the $1 trillion you're putting down will be utilized, would be performant, would be incredibly cost-effective, and have useful life for as long as you could see. That infrastructure investment you could make on NVIDIA, you could make with complete confidence. We have now proven that. It is the only infrastructure in the world that you could go anywhere in the world and build with complete confidence. You want to put it in any of the clouds, we're delighted by that. You want to put it on-prem, we're happy about that. You want to put it in any country, anywhere, we're delighted to support you. We are now a computing platform that runs all of AI. Now, our business already starting to show that. 60% of our business is hyperscalers, the top 5 hyperscalers. However, even within that top 5 hyperscalers, some of it is internal AI consumption. The internal AI consumption, really important work, like Rexis is moving from recommender systems of tables and collaborative filtering and content filtering. It's moving towards deep learning and large language models. Search, moving to deep learning, large language models. Almost all of these different hyperscale workloads are now moving, shifting towards a workload that NVIDIA GPUs are incredibly good at. But on top of that, because we work with every AI lab, because we work with every AI, we accelerate every AI model, and because we have a large ecosystem of AI natives that we work with that we can bring to the clouds, that investment, no matter how large, no matter how quick, that compute will be consumed. And that represents 60% of our business. The other 40% is just everywhere. Regional clouds, sovereign clouds, enterprise, industrial, robotics, edge, big systems, supercomputing systems, small servers, enterprise servers. The number of systems, incredible. The diversity of AI is also its resilience. The span of reach of AI is its resilience. There is no question this is not a one-app technology. This is now fundamental. This is absolutely a new computing platform shift. Well, our job is to continue to advance the technology, and one of the most important things that I mentioned last year was our year of inference. We dedicated everything. We took a giant chance and reinvented while Hopper was at its prime and it was just cooking. We decided that the Hopper architecture, the NVLink by 8, had to be taken to the next level. We completely re-architected the system, disaggregated the computing system altogether, and created NVLink 72. The way that it's built, the way it's manufactured, the way it's programmed completely changed. Grace Blackwell NVLink 72 was a giant bet. And it wasn't easy for anybody. And many of my partners here in the room, I want to thank all of you for the hard work that you guys did. Thank you. NVLink 72, NVFP4, not just FP4 precision. FP4 is a whole different type of tensor core and computational unit. We've demonstrated now that we can inference NVFP4 without loss of precision, but gigantic boost in performance and energy efficiency. We've also been able to use NVFP4 for training. So NVLink 72, NVFP4, the invention of Dynamo, TensorRT LLM, a whole bunch of new algorithms. We even built a supercomputer to help us optimize kernels and help us optimize our complete stack. We call it DGX Cloud. We invested billions of dollars of supercomputing capability, help us create the kernels, the software that made inference possible. Well, the results all came together, and people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from SemiAnalysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, is tokens per watt. Tokens per watt is important because every data center, every single factory, by definition, is power constrained. A 1 gigawatt factory will never become 2. It's physically constrained. The laws of atoms, the laws of physicality. And so that 1 gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference. The faster you can inference, the faster you could, of course, respond. But very importantly, the faster you can inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO in the world will study their business from now on in the way I'm about to describe. Because this is your token factory. This is your AI factory. This is your revenues. There's no question about that going forward. And so this is the throughput. This is the intelligence. Better perf per watt for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, NVIDIA is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's Law would have given us, through transistors, 50%, 2 times, Moore's Law would probably give us 1.5 times more performance. You would have expected from Hopper H200 1.5 times higher. Nobody would have expected 35 times higher. I said last year at this time that NVIDIA's Grace Blackwell NVLink 72 was 35 times perf per watt. Nobody believed me. And then SemiAnalysis came out, and Dylan Patel had a quote. He accused me of sandbagging. He accused me of sandbagging. He says, Jensen sandbagged. It's actually 50 times. And he's not wrong. He's not wrong. And so our cost per token, our cost per token is the lowest in the world. You can't beat it. I've said before, if you have the wrong architecture, even if it's free, it's not cheap enough. And the reason for that is because no matter what happens, you still have to build a gigawatt data center. You still have to build a gigawatt factory. And that gigawatt factory, for 15 years amortized across, that gigawatt factory is about $40 billion. Even when you put nothing on it, it's $40 billion in. You better make for darn sure you put the best computer system on that thing so that you could have the best token cost. NVIDIA's token cost is world-class, basically untouchable at the moment. And the reason that's true is because of extreme co-design. And so I'm very happy that he named us There was a monkey king, token king. Well, we take all of our software, as I told you, we vertically integrate, but we horizontally open. We're vertical integration, horizontal open. We integrate all of our software and all of our technology, however we could package it up and integrate it into the world's inference service providers. And these companies are growing so fast. They're growing so fast. Fireworks, Lynn is here, Together. They're just growing so incredibly fast. 100 times in the last year. They are token factories. And the effectiveness, the performance, and the token cost production capability for their factories is everything to them. And this is what happened. We updated their software, same system, and notice their token speeds, incredible. The difference, before NVIDIA updated everything and all of our algorithms and software and all the technology that we bring to bear, about 700 tokens per second average went to nearly 5,000, 7 times higher. And so this is the incredible power of extreme co-design. I mentioned earlier the importance of factories. This is the importance of factory. Your data center, it used to be a data center for files. It's now a factory to generate tokens. Your factory is limited no matter what. Everybody's looking for land, power, and shell. Once you build it, you are power limited. Within that power limited infrastructure, you better make for darn sure that your inference, because you know inference is your workload and tokens is your new commodity, that compute is your revenues, that you want to make sure that the architecture is as optimized as you can. In the future, every single CSP, every single computer company, every single cloud company, every single AI company, every single company, period, are going to be thinking about their token factory effectiveness. This is your factory in the future. And the reason why I know that is because everybody in this room is powered by intelligence. And in the future, that intelligence will be augmented by tokens. So let me show you how we got here. On April 6th, 2016, a decade ago, we introduced DGX-1, the world's first computer designed for deep learning. 8 Pascal GPUs connected with the In 2020, DGX-A100 SuperPod became the first GPU supercomputer combining scale-up and scale-out architecture. NVLink 3 for scale-up, ConnectX-6, and Quantum InfiniBand for scale-out. Then Hopper, the first GPU with the FP8 transformer engine that launched the generative AI era. NVLink 4, ConnectX-7, Bluefield 3 DPUs, second generation Quantum InfiniBand. It revolutionized computing. Blackwell redefined AI supercomputing system architecture with NVLink 72. 72 GPUs connected by NVLink Spine. 130 terabytes per second of all-to-all bandwidth. Compute trays integrate Blackwell GPUs, Grace CPUs, ConnectX-8, and Bluefield 3. Scale-out runs over Spectrum 4 Ethernet. With 3 scaling laws in full steam, pre-training, post-training, and inference, and now agentic systems, compute demand continues to grow exponentially. And now, Vera Rubin. Architected for every phase of agentic AI, advancing every pillar of computing, including CPU, storage, networking, and security. Vera Rubin NVLink 72. In just 10 years. Now, in the good old days, when I would say Hopper, I would hold up a chip. That's just adorable. This is Vera Rubin. When we think when we think Vera Rubin, we think the entire system, vertically integrated, completely with software, extended end to end, optimized as one giant system. The reason why it's designed for agentic systems is very clear, because agents, of course, the most important workload is it's thinking the large language model. The large language models are going to get larger and larger and larger. It's going to generate more and more tokens more quickly so it can think more quickly, but it also has to access memory. It's going to pound on memory really hard. KV cache, structured data, QDF, unstructured data, QVS. It's going to be pounding on the storage system really, really hard, which is the reason why we reinvented the storage system. It is also going to use tools. And unlike humans that are more tolerant to slower computers, AI wants the tools to be as fast as possible. These tools, web browsers, in the future, they could also be virtual PCs in the cloud. Those PCs have to be, and those computers have to be as fast as possible. We created a brand new CPU that's designed for extremely high single-threaded performance, incredibly high data output, incredibly good at data processing, and extreme energy efficiency. It is the only data center CPU in the world that uses LPDDR5, and incredible single-threaded performance and performance per watt that is unrivaled. And so we built that so that it could go along with the rest of these racks for agentic processing. And so here it is. This is the Grace Blackwell, Vera Rubin, where is it? Here it is, okay? So this is the Vera Rubin system. Notice, since the last time, 100% liquid cooled. All of the cables gone. What used to take 2 days to install now takes 2 hours. Incredible. And so the manufacturing cycle time is going to dramatically reduce. This is also a supercomputer that is cooled by hot water, 45 degrees, which takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center and makes it available for the system. This is the secret sauce. We're the only company in the world that has today built the sixth generation scale-up switching system. This is not Ethernet. This is not InfiniBand. This is NVLink. This is the 6th generation NVLink. This is insanely hard to do well. It is insanely hard to do, period. And I'm just super proud of the team. NVLink, completely liquid cooled. This is the brand new Grok system, and I'll show you a little bit more about it. This system, 8 Grok chips. This is the LP30. The world's never seen it. Anything that the world's ever seen is V1. This is 3rd generation. And we're in volume production now. And I'll show you more about that in just a second. The world's first CPO Spectrum-X switch. This is also in full production. Co-packaged optics. Optics comes directly onto this chip, interfaces directly to silicon. Electrons get translated to photons, and it gets directly connected to this chip. We invented the process technology with TSMC. We're the only one in production with it today. It's called COUP. It's completely revolutionary. NVIDIA is in full production with Spectrum-X. This is the Vera system, twice the performance per watt of any CPUs in the world today. It is also in production. Well, you know, we never thought we would be selling CPUs standalone. We are selling a lot of CPUs standalone. This is already, for sure, going to be a multi-billion-dollar business for us. So I'm very, very pleased with our CPU architects. We've designed a revolutionary CPU. And this is the CX9 powered with Vera CPU, the Bluefield 4 STX, our new storage platform. Okay, so these are the racks. and it's connected. Each one of these racks, the NVLink rack, this is, I've shown you guys this before, it's just super heavy and seems to get heavier every year. Because I think there's just more cables in there every year. And so this is the NVLink rack. We've also taken this technology because it is so efficient to create a data center with these cabling systems, structured cables. So we decided to do that for Ethernet. So this is Ethernet, 256 liquid-cooled nodes in one rack, and it is also connected with these incredible connectors. You guys want to see Rubin Ultra? So this is the Rubin Ultra compute node. Unlike Rubin that slides in horizontally, Rubin Ultra goes into a whole new rack. It's called Kyber, that enables us to connect 144 GPUs in one NVLink domain. And so the Kyber rack, this, I could lift it, I'm sure, but I won't. It's quite heavy. This is one compute node, and it slides into the Kyber rack vertically. This is where it connects into. This is the midplane. The Kyber racks, those four top NVLink connectors slide in and connect into this, and this becomes one of the nodes. And each one of these racks is a different compute node, and this is the amazing part. This is the midplane, and the back of the midplane, instead of the cabling system, which has its limits in terms of how far we could drive cables, copper cables, we now have this system to connect 144 GPUs. This is the new NVLink. This sits also vertically, and it connects into the midplanes on the back. Compute in the front, NVLink switches in the back, one giant computer, okay? So that is Rubin Ultra. As I mentioned, how about we take this back down? I need the rest of my slides. Oh, it's coming down? Okay. Thank you, Janine. This is what happens when you don't practice. Okay, all right, so take your time, just don't get hurt. You saw this slide. You know, only at NVIDIA's keynote will you see last year's slide presented again. And the reason for that is I just want to let you know that last year I told you something very, very important. And it's so important, it's worthwhile to tell you again. This is probably the single most important chart for the future of AI factories. And every CEO in the world will be tracking it, will be studying it very deeply. It's much, much more complicated than this. It's multi-dimensional. But you will be studying the throughput and the token speed of your AI factories. The throughput, token speed at ISO power, because that's all the power you have, throughput and token speed for your factories forever. And that analysis is going to lead directly to your revenues. What you do this year will show up precisely next year as your revenues. And this chart is what it's all about. And I said on the vertical axis, thank you guys, on the vertical axis is throughput, on the horizontal axis is token rate. Today, I'm going to show you this. Because we're now able to increase the token speed, and because model sizes are increasing, because the token length, the context length, depending on the different grades of different application use case, continues to grow, from maybe 100,000 tokens input length to maybe millions. The token input length is growing, and also the output token length is growing. And so all of these play into, ultimately, the marketing and the pricing of future tokens. Tokens are the new commodity, and like all commodities, once it reaches an inflection, once it becomes mature or becomes maturing, it will segment into different parts. The high throughput, low speed could be used for the free tier. The next tier could be the medium tier. Larger model maybe, higher speed for sure, larger input context length. That translates to a different price point. You could see from all the different services, this one is free, it's a free tier. The first tier could be $3 per million tokens. The next tier could be $6 per million tokens. You would like to be able to keep pushing this boundary because the larger the model, smarter. The more input token context length, more relevant. The higher the speed, the more you can think and iterate, smarter AI models. So this is about smarter AI models. And when you have smarter AI models, each one of these clicks allows you to increase the price. So this is $45. And maybe one day there'll be a premium model that allows you, a premium service that allows you to generate token speeds that are incredibly high because you're in a critical path, or maybe you're doing really long research, and $150 per million tokens is just not a thing. So let's translate that. Suppose you were to use 50 million tokens per day as a researcher at $150 per million tokens. As it turns out, as a research team, that's not even a thing. So we believe that this is the future. This is where AI wants to go. This is where it is today. It had to start here to establish the value and establish its usefulness and get better and better and better. In the future, you're going to see most services encompass all of that. This is Hopper. Hopper started, and I moved the chart. This is 50, this is 100. Hopper looks like this. And you would have expected Hopper, the next generation, to be higher, but nobody would have expected it to be that much higher. This is Grace Blackwell. What Grace Blackwell did is, at your free tier, increase your throughput tremendously. However, where you mostly monetize your service, it increased your throughput by 35 times. This is no different than any product that every company makes. The higher the tier, the higher the quality, the higher the performance, the lower the volume, the lower the capacity. And so it is no different than any other business in the world. And so now we're able to increase this tier by 35x. And we introduced a whole new tier. This is the benefit of Grace Blackwell, a huge jump over Hopper. Well, this is what we're doing with. Okay, so this is Grace Blackwell. Okay, let me just reset this. And this is Vera Rubin. Okay? Now just think what just happened. At every single tier, we increase the throughput. And at the tier where your highest ASP and your most valuable segment, we increased it by 10x. That is the hard work. This is incredibly hard to do out here. This is the benefit of NVLink 72. This is the benefit of extremely low latency. This is the benefit of extreme co-design, that we could shift the entire area up. Now, what does it mean from a customer perspective in the end? Suppose I were to take all of that and I just, multiply it against. Suppose I took 25% of my power, used it in a free tier, 25% of my power in the medium tier, 25% of my power in the high tier, and 25% of my power in the premium tier. My data center only has 1 gigawatt. And so I get to decide how I want to distribute. The free tier allows me to attract more customers. This allows me to serve my most valuable customers. And the combination, the product of all that, allows you basically your revenues. The revenues you can generate, assuming this simplistic example, allows Blackwell to generate 5 times more revenues Vera Rubin to generate 5 times. Yeah. So Vera Rubin, you should get there as soon as you can. And the reason for that is because your cost of tokens goes down and your throughput goes up. Now, but we want even more. We want even more. And so let me just show you back to this. This is, as I told you, this throughput requires a ton of flops. This latency, this interactivity requires enormous amount of bandwidth. Computers don't like extreme amount of flops, extreme amount of bandwidth, because there's only so much surface area for chips that any systems has. And so optimizing for high throughput and optimizing for low latency are, in fact, enemies of each other. And so this is what happened when we combined with Groq. Okay? And so we acquired a team that worked on the Groq chips and licensed the technology, and we've been working together now to integrate the system. This is what that looks like. So at the most valuable tier, we're now going to increase performance by 35x. Now, this very simple chart revealed to you exactly the reason why NVIDIA is so strong in the vast majority of the workloads so far. And the reason for that is because up in this area, throughput matters so much. NVLink 72 is so game-changing. It is exactly the right architecture, and it's even hard to beat, even as you add Groq to it. However, if you extended this chart way out here and you said you wanted to have services that delivers not 400 tokens per second, but 1,000 tokens per second, all of a sudden, NVLink 72 runs out of steam and it simply can't get there. We just don't have enough bandwidth. And so this is where Groq comes in, and this is what happens when we push that out. So it goes out beyond, thank you. Goes out beyond even the limits of what NVLink 72 can do. And if you were to do that, translate that into revenues, relative to Blackwell, Vera Rubin is 5x. If most of your workload is high throughput, I would stick with just 100% Vera Rubin. If a lot of your workload wants to be coding and very high valued engineering, token generation, I would add Groq to it. I would add Groq to maybe 25% of my total data center. The rest of my data center is all 100% Vera Rubin. And so that gives you a sense of how you would add Groq to Vera Rubin and extend its performance and extend its value even more. This is what happens. This is a contrast. The reason why Groq was so attractive to me is because their computing system, a deterministic data flow processor, it is statically compiled, it is compiler scheduled, meaning the compiler figures out when the compute and the data arrives at the same time. All of that is done statically in advance and scheduled completely in software. There's no dynamic scheduling. The architecture is designed with massive amounts of SRAM. It is designed just for inference, this one workload. Now, this one workload, as it turns out, is the workload of AI factories. And as the world continues to increase the amount of high-speed tokens it wants to generate with super smart tokens it wants to generate, the value of this integration is going to get even higher. And so these are two extreme processors you could see. One chip, 500 megabytes. One Vera Rubin chip, 288 gigabytes. It would take a lot of Groq chips to be able to hold the parameter size of Rubin, as well as all of the context that has to go, the KV cache that has to go along with it. So that limited Groq's ability to really reach the mainstream, to really take off, until we had a great idea. What if we disaggregated inference altogether with a piece of software called Dynamo? What if we re-architected the way that inference is done in the pipeline so that we could put the work that makes perfect sense on Vera Rubin and then offload the decode generation, the low latency, the bandwidth limited, challenged part of the workload for Groq? And so we unified 2 processors of extreme differences, one for high throughput, one for low latency. It still doesn't change the fact that we need a lot of memory. And so Groq, we're just going to add a whole bunch of Groq chips, which expands the amount of memory it has. And so if you could just imagine, out of a trillion parameter model, we have to store all of that in Groq chips. However, it sits next to NVIDIA Vera Rubin, where we could hold the massive amounts of KV cache that's necessary in processing all of these agentic AI systems. It's based upon this idea of disaggregated inference. We do the prefill, that's the easy part, but we also tightly integrate the decode. So the attention part of decode is done on NVIDIA's Vera Rubin, which needs a lot of math, and the feed-forward network part of it, the decode part, is done, the token generation part is done on Vera Rubin, on the Groq chip. The 2 of them working tightly coupled together over, today, Ethernet, with a special mode to reduce its latency by about half. And so that capability allows us to integrate these 2 systems. We run Dynamo, this incredible operating system for AI factories on top of it, and you get 35 times increase. 35 times increase, not to mention additional new tiers of inference performance for token generation the world's never seen. So this is it. This is Groq. The Vera Rubin systems, including Groq, I want to thank Samsung, who manufactures the Groq LP30 chip for us, and they're cranking as hard as they can. I really appreciate you guys. We're in production with the Groq chip, and we'll ship it in the second half, probably about Q3 timeframe. Okay? Groq LPX. Vera Rubin, it's kind of hard to imagine any more customers. The really great thing is Grace Blackwell's early sampling of it was really complicated because of coming together of NVLink 72, but the sampling of Vera Rubin is just going incredibly well. And in fact, Satya, I think, texted out already that the first Vera Rubin rack is already up and running at Microsoft Azure. And so I'm super excited for them. We're going to keep cranking these things out. We have now set up a supply chain that could manufacture thousands a week of these systems, essentially multi-gigawatts of AI factories per month inside our supply chain. And so we're going to crank out these Vera Rubin racks while we're cranking out the GB300 racks. We are in full production. The Vera CPUs, incredibly successful. And the reason for that is because AI needs CPUs for tool use. And Vera CPU was designed just perfectly for that sweet spot. Incredible for the next generation of data processing. Vera CPU is ideal. The Vera CPU plus CX9 connected into the Bluefield 4 stack. 100% of the world's storage industry is joining us on this system. And the reason for that is because they see exactly the same thing. The storage system is going to get pounded. It's going to get pounded because we used to have humans using the storage systems. We used to have humans using SQL. Now we're going to have AIs using these storage systems. And it's going to store cuDF accelerated storage, cuVS accelerated storage, as well as, very importantly, KV caching. Okay, so this is the Vera Rubin system. Now what's amazing is this. In just 2 years' time, in a 1 gigawatt factory, in just 2 years' time, in 1 gigawatt factory, using the mathematics that I showed you earlier, whereas Moore's law would have given us a couple of steps, we would have, X-factored the number of transistors, we would have X-factored the number of flops, we would have X-factored the amount of bandwidth. But with this architecture, we're going to take our token generation speed, token generation rate from 2 million to 700 million, 350 times increase. This is the power of extreme co-design. This is what I mean when we integrate and optimize vertically, but then we open it horizontally for everybody to enjoy. This is our roadmap. Very quickly, Blackwell is here, the Oberon system. In the case of Rubin, we have the Oberon system. We're always backwards compatible so that if you wanted to not change anything and just keep on moving through with the new architecture, you could do so. The old system, the standard rack system, Oberon, still available. Oberon is copper scale up, and with Oberon, we could also use optical scale out, or excuse me, optical scale up to expand to NVLink 576. Okay? And so there's a lot of conversation about, is NVIDIA going to copper scale up or optical scale up? We're going to do both. So we're going to have NVLink 144 with Kyber, and then with Oberon, we're going to NVLink 72 plus optical to get to NVLink 576. The next generation of Rubin, with Rubin Ultra, we have the Rubin Ultra chip, which is coming, which is taping out, and we have a brand new chip, LP35. LP35 will, for the first time, incorporate NVIDIA's NVFP4 computing structure. Give you another few X factor speed up. Okay, and so this is Oberon, NVLink 72, optical scale up, and it uses Spectrum 6, the world's first co-packaged optical, and all of this is in production. The next generation from here is Feynman. Feynman has a new GPU, of course. It also has a new LPU, LP40, big step up, incredible, incredible new technology. Now, uniting the scale of NVIDIA and the Grok team, building together LP40, it's going to be incredible. A brand new CPU called Rosa, short for Rosalind. Bluefield 5, which connects the next CPU with the next Super NIC, CX10. We will have Kyber, which is copper scale up. We will also have Kyber CPO scale up. So for the first time, we will scale up with both copper and co-packaged optics. Okay? And so a lot of people have been asking, you know, Jensen, is copper going to still be important? The answer is yes. Jensen, are you going to scale up optical? Yes. Are you going to scale out optical? Yes. And so for everybody who's in our ecosystem, we need a lot more capacity. And that's really the key. We need a lot more capacity for copper. We need a lot more capacity for optics. We need a lot more capacity for CPO. And that's the reason why we've been working with all of you to lay the foundation for this level of growth. And so Feynman will have all of that. Let me see if I missed everything. That's it. Every single year, brand new architecture. Very quick. Very quickly, NVIDIA went from a chip company to an AI factory company, or AI infrastructure company, AI computing company, these systems. And now we're building entire AI factories. There's so much power that is squandered in these AI factories. We want to make sure that these AI factories come together, designed in the best possible way. Most of these components never meet each other. Most of us technology vendors, now we all know each other. But in the past, we never met each other until the data center. That can't happen. We're building super complex systems. And so we have to meet each other virtually somewhere else. And so we created Omniverse, and the Omniverse DSX world, a platform where all of us can meet and design these gigafactories, gigawatt AI factories virtually in system. We have simulation systems for the racks for mechanical, thermal, electrical, networking, those simulation systems integrated into all of our ecosystem partners of incredible tools companies. We also operated, connected to the grid so that we could interact with each other, send each other information so that we could adjust grid power and data center power accordingly, saving energy. And then inside the data center, using Max-Q so that we could adjust the system dynamically across power and cooling and all of the different technologies we all work on together so that we leave no power squandered, so that we run at the most optimal rate to deliver enormous amount of token throughput. There's no question in my mind there's a factor of 2 in here. And the factor of 2 at the scale we're talking about is gigantic. We call this the NVIDIA DLSS platform. And just as all of our platforms, there's the hardware layer, there's the library layer, and there's the ecosystem layer. It's exactly the same way. Let's show it to you. The greatest infrastructure build-out in history is underway. The world is racing to build chip, system, GTC Windchill PLM. Then, model-based systems engineering is done in Dassault Systems 3D Experience. Jacobs brings the data into their custom Omniverse app. Well, Omniverse was designed to hold the world's digital twin, starting from the Earth. And it's going to hold digital twins of all sizes. And so we have just such a great ecosystem of partners. I want to thank all of you. All of these companies are brand new to our world. We didn't know many of you just a couple of years ago. And now we're working so close together to work on and build together the largest computer the world's ever seen, and also to do it at planetary scale. So NVIDIA DSX is our new AI factory platform. I'll spend very little time on this time. However, we're going to space. We've already been out in space. Thor is radiation approved, and we're in satellites. You do imaging from satellites. In the future, we'll also build data centers in space. Obviously, very complicated to do so. We're working with our partners on a new computer called Vera Rubin Space One, and it's going to go out to space and start data centers out in space. Now, of course, in space, there's no conduction, there's no convection, there's just radiation. And so we have to figure out how to cool these systems out in space. But we've got lots of great engineers working on it. Let me talk to you about something new. So Peter Steinberger's here, and he wrote a piece of software. It's called OpenClaw, and I don't know if he realized how successful it's going to be, but the importance is profound. OpenClaw is the #1, it's the most popular open source project in the history of humanity, and it did so in just a few weeks. It exceeded what Linux did in 30 years. And it's that important. It is that important. It will do, well, this is all you do, okay? We're announcing our support of it. Let me just quickly go through this. I want to show you a couple things. You simply type this. You type this into a console, and it goes out. It finds OpenClaw. It downloads it. It builds you an AI agent, and then you could tell it whatever else you need to do. Okay? So let's take a look.
Stuff enables that person to do. And we had like one guy, he told me like he installed it at his 60-year-old dad, and like they made beer, connected the machine via Bluetooth to OpenClaw, and then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
Hundreds of people are queuing up for lobsters in Shenzhen.
OpenClaw. We want to build OpenClaw with OpenClaw.
Everyone is talking about OpenClaw, but what is OpenClaw?
Believe it or not, there's already a claw con.
Incredible, incredible. Now, I illustrated effectively what OpenClaw is in this way, and so that all of you can understand it, but let's just think what happened. What is OpenClaw? It connects, it's an agentic system. It calls and connects to large language models. So the first thing it has resources that it manages. It could access tools, it could access file systems, it could access large language models. It's able to do scheduling. It's able to do cron jobs. It's able to decompose a prompt that you gave it into step by step by step. It could spawn off and call upon other sub-agents. It has I/O. You could talk to it in any modality you want. You could wave at it and it understands you. You could talk to any modality you want. It sends you messages. It texts you, sends you email. So it's got I/O. What else does it have? Well, based on that, you could say, in fact, it's an operating system. I've just used the same syntax that I would describe an operating system. OpenClaw has open sourced essentially the operating system of agentic computers. It is no different than how Windows made it possible for us to create personal computers. Now OpenClaw has made it possible for us to create personal agents. The implication is incredible. The implication is incredible. First of all, the adoption says something, all in itself. However, the most important thing is this. Every single company now realize, every single company, every single software company, every single technology company, for the CEOs, the question is, what's your OpenClaw strategy? Just as we need to all have a Linux strategy, we all needed to have an HTTP, HTML strategy, which started the internet. We all needed to have a Kubernetes strategy, which made it possible for mobile cloud to happen. Every company in the world today needs to have an OpenClaw strategy, an agentic system strategy. This is the new computer. Now, this is just the exciting part. This is enterprise IT before OpenClaw, and I mentioned earlier, the way enterprise IT works, and the reason why it's called data centers is because these large rooms, these large buildings held data, held the files of people, the structured data of business. It would pass through software that has tools and systems of records and all kinds of workflow that's codified into it, and that turns into tools that humans would use, digital workers would use. That is the old IT industry. Software companies creating tools, saving files, and of course, GSI's consultants that help companies figure out how to use these tools and integrate these tools. These tools are incredibly valuable for governance and security and privacy and compliance, and all of that continues to be true. It's just that post-OpenClaw, post-agentic, this is what it's going to look like. This is the extraordinary part. Every single IT company, every SaaS company will become a gas company. No question about it. Every single SaaS company will become a gas company, an agentic as a service company. And what's amazing is this, OpenClaw gave the industry exactly what it needed at exactly the time. Just as Linux gave the industry exactly what it needed at exactly the time, just as Kubernetes showed up at exactly the right time, just as HTML showed up. It made it possible for the entire industry to grab onto this open source stack and go do something with it. There's just one catch. Agentic systems in the corporate network can have access to sensitive information, it can execute code, and it can communicate externally. Just say that out loud, okay? Think about it. Access sensitive information, execute code, communicate externally. You could, of course, access employee information, access supply chain, access finance information, sensitive information, and send it out, communicate externally. Obviously, this can't possibly be allowed. And so what we did was we worked with Peter. We took some of the world's best security and computing experts, and we worked with Peter to make OpenClaw enterprise secure and enterprise private capable. And we call that, this is our NVIDIA OpenClaw reference for NemoClaw, which is a reference for OpenClaw, and it has all these agentic AI toolkits, and the first part of it is technology we call OpenShell that has now been integrated into OpenClaw. Now it's enterprise ready. This stack with a reference design we call NemoClaw, okay? With a reference stack we call NemoClaw, you could download it, play with it, and you could connect to it the policy engine of all of the SaaS companies in the world. And your policy engines are super important, super valuable. So the policy engines could be connected. NemoClaw or OpenClaw with OpenShell would be able to execute that policy engine. It has a network guardrail. It has a privacy router. And as a result, we could protect and keep the claws from executing inside our company and do it safely. We also added several things to the agentic system. And one of the most important things you want to do with your own custom claws is so that you can have your custom models. And this is NVIDIA's Open Model Initiative. We are now at the frontier of every single domain of AI models. Whether it's Nemotron, Cosmos World Foundation model, Groot, artificial general robotics, humanoid robotics models, AlphaMyo for autonomous vehicle, BioNemo for digital biology, Earth-2 for AI physics. We are at the frontier on every single one. Take a look.
The world is diverse. No single model can serve every industry. Open Models is one of the largest and most diverse AI ecosystems in the world. Nearly 3 million open models across language, vision, biology, physics, and autonomous systems enable AI builds for specialized domains. NVIDIA is one of the largest contributors to open source AI. We build and release 6 families of open frontier models, plus the training data, recipes, and frameworks to help developers customize and adopt. New leaderboard topping models are launching for every family. At the core, Nemotron.
Our models, thank you. Our models are valuable to all of you because number one, it's on the top of the leaderboard. It's world class. But most importantly, it's because we are not going to give up working on it. We're going to keep on working on it every single day. Nemotron 3 is going to be followed by Nemotron 4. Cosmos 1 was followed by Cosmos 2. Groot at generation 2. Each and one of these, we're going to continue to advance these models. Vertical integration, horizontal openness, so that we can enable everybody to join the AI revolution. Number one on leaderboard across research and voice and world models and artificial general robotics and self-driving cars and reasoning. And of course, one of the most important one, this is Nemotron 3 in OpenClaw. This is Nemotron 3 in OpenClaw. And look at the top 3. There are the 3 best models in the world. Okay, so we are at the frontier. It is also true that we want to create the foundation model so that all of you could fine-tune it and post-train it into exactly the intelligence you need. This is Nemotron 3 Ultra. It is going to be the best base model the world's ever created. This allows us to help every country build their sovereign AI. And we're working with so many different companies out there. And one of the most exciting things that we're doing today, I'm announcing today, is a Nemotron coalition. We are so dedicated to this. We have invested billions of dollars of AI infrastructure so that we could develop the core engines for AI that's necessary for all the libraries of inference and so on, but also to create the AI models to activate every single industry in the world. Large language models is really important. Of course it's important. How could human intelligence not be? However, in different industries around the world, in different countries around the world, you need to have the ability to customize your own models, and the domain of the models is radically different, from biology to physics to self-driving cars to general robotics to, of course, human language. And we have the ability to work with every single region to create their domain-specific, their sovereign AI. Today, we're announcing a coalition to partner with us to make Nemotron 4 even more amazing. And that coalition has some amazing companies in it. Black Forest Labs, imaging company, Cursor, the famous coding company, we use lots of it, LangChain, billion downloads for creating custom agents, Mistral, the Arthur mentioned, I think he's here, incredible company, Perplexity's computer, absolutely use it. Everybody use it. It is so good. A multimodal agentic system, Reflection, Sarvam from India, Thinking Machine, Mira Murati's lab. Incredible companies joining us. Thank you. I said that every single enterprise company, every single software company in the world needs an agentic systems, need an agent strategy. You need to have an open claw strategy, and they all agree. And they're all partnering with us to integrate Nemo, the Nemo Claw reference design, the NVIDIA Agentic AI Toolkit, and of course, all of our open models. One company after another, there's so many, and we're partnering with all of you. I'm really grateful for that. And this is our moment. This is a reinvention. This is a renaissance of the enterprise IT. From what would be a $2 trillion industry, this is going to become a multi-trillion-dollar industry, offering not just tools for people to use, but agents that are specialized in very special domains that you're expert in, that we could rent. I could totally imagine in the future, every single engineer in our company will need an annual token budget. They're gonna make a few $100,000 a year, their base pay. I'm gonna give them probably half of that on top of it as tokens so that they could be amplified 10x. Of course we would. It is now one of the recruiting tools in Silicon Valley. How many tokens comes along with my job? And the reason for that is very clear, because every engineer that has access to tokens will be more productive. And those tokens, as you know, will be produced by AI factories that all of you and us, we partner to build, okay? So every single enterprise company in today sit on top of file systems and data centers. Every single software company of the future will be agentic, and they will be token manufacturers. There'll be token users for their engineers, and there'll be token manufacturers for all of their customers. The Open Claw event cannot be understated. This is as big of a deal as HTML. This is as big of a deal as Linux. We have now a world-class open agentic framework that all of us could use to build our Open Claw strategy. And we've created a reference design we call Nemo Claw, that all of you could use, that is optimized, it's performant, it is safe and secure. Speaking of agents, as you know, perceive, reason, and act. Most of the agents in the world today that I've spoken about are digital agents. They act in the digital world. They reason, they write software. It's all digital. But we also have been working on physically embodied agents for a long time. We call them robots. And the AIs that they need are physical AIs. We have some big announcements here. I'm going to just walk through a few of them. 110 robots here. Almost every single company in the world, I can't think of one, that are building robots is working with NVIDIA. We have 3 computers, the training computer, the synthetic data generation and simulation computer, and of course the robotics computer that sits inside the robot itself. We have all the software stacks necessary to do so, the AI models to help you. And all of this is integrated into ecosystems around the world, and all of our partners from Siemens to Cadence, incredible partners everywhere. And today we're announcing a whole bunch of new partners. As you know, we've been working on self-driving cars for a long time. The ChatGPT moment of self-driving cars has arrived. We now know we could successfully autonomously drive cars. And today we are announcing 4 new partners for NVIDIA's robotaxi-ready platform. BYD, Hyundai, Nissan, Geely, all together, 18 million cars built each year, joining our partners from before, Mercedes, Toyota, GM. The number of robo-taxi-ready cars in the future are going to be incredible. And we're announcing also a big partnership with Uber. Multiple cities, we're going to be deploying and connecting these robo-taxi-ready vehicles into their network. And so a whole bunch of new cars. We have ABB, Universal Robotics, KUKA, so many robotics companies here. And we're working with them to implement our physical AI models integrated into simulation systems so that we could deploy these robots into manufacturing lines all over. We have Caterpillar here. We even have T-Mobile here. And the reason for that is in the future, that radio tower used to be a radio tower, is going to be an NVIDIA aerial AI RAN. And so this is going to be a robotics radio tower, meaning it can reason about the traffic, figure out how to adjust its beamforming so that it could save as much energy as possible and increase the amount of fidelity as possible. There's so many humanoid robots here, but one of my favorites is a Disney robot. You know what? Tell you what, let me just show you some of the videos. Let's look at that first.
Developers everywhere are closing the physical AI data gap. Paratas AI trains their operating room assistant robot in NVIDIA Isaac Lab, multiplying their data with NVIDIA Cosmos World models. Skilled AI uses Isaac Lab and Cosmos to generate post-training data for their skilled AI brain. They use reinforcement learning to harden the model across thousands of variations. Humanoid uses Isaac Lab to train whole body control and manipulation policies. Hexagon Robotics uses Isaac Lab for training and data generation. Foxconn fine-tunes group models in Isaac Lab, as does Noble Machines. Disney Research uses their Camino physics simulator in Newton and Isaac Lab to train policies across their character robots in every universe.
Ladies and gentlemen, Olaf. Does it?
Snowman coming through. Pardon me.
Newton
Hello.
works.
Wow.
Omniverse works. Olaf, how are you?
I'm so happy now that I'm meeting you.
I know, because I gave you your computer, Jetson.
What's that?
Well, it's in your tummy.
That's gonna be amazing.
And you learn how to walk inside Omniverse.
I love walking. This is so much better than riding on a reindeer gazing up at a beautiful sky.
And it was because of physics, using this Newton solver that runs on top of NVIDIA Warp, that we jointly developed with Disney and with DeepMind, that made it possible for you to be able to adapt to the physical world. Check that out.
I was just about to say that.
That's how smart you are.
I'm a snowman, not a snowclopedia.
Could you imagine this? The future of Disneyland? All these robots, all these characters wandering around.
Oh!
You know, I have to admit though, I thought you were going to be taller. I've never seen such a short snowman, to be honest.
Nope.
Hey, tell you what, you want to help me out?
Hooray!
Okay. Usually I close the keynote by telling you what I told you. We talked about inference inflection, we talked about the AI factory, we talked about the open claw agent revolution that's happening, and of course we talked about physical AI and robotics. But tell you what, why don't we get some friends to help us close it out?
Of course.
All right, play it. Come on.
Terminating simulation.
Hello? Anybody here?
The keynote's over, all was said. Jensen mapped the road ahead. AI factories coming alive. Agents learning how to drive. From open models to robots too. Now we'll break it all down for you. Compute exploded what we saw. From CNNs to OpenClaw. Agents working across the land, but they need the power to meet demand. So we solved the problem, it was brilliant. We multiplied compute by 40 million. prone in AI. Time training was the paradigm. Sure, it taught the models how, but inference runs the whole world now. Vera shows us who's the boss at 35 times less the cost. Blackwell makes the tokens sing. NVIDIA, the inference king. Yeah, our factories once took years, vendors pulling racks and gears, built up slowly piece by piece, no clear way to scale this beast. DSX and Dynamo know what to do, turning power into revenue. Agents used to wait and see, now act autonomously, but if they ever try to stray, safe clause block and say no way. Nemo clause there to guard the course. And yes, my friends, it's open source. Cars that think and droids that run, this ain't the movies, it's all begun. Alpha Mayo calls the shots, it's a GPT moment for the bots from sim to streets. Now watch them drive, throw your hands up for physical AI. Industrial age built what came before, now we build for AI even more. Vera Rubin plus Grok make the inference splash, put them together, now it's raining cash. We build new architecture every year, cause claws keep yelling more tokens here. The AI stacks for all to make, so let us all eat 5-layer cake. The moment's bright, the path is clear, cause open models led us here. When data's missing, there's no dispute, we just generate more with compute. Robots learning without flaw, fueling the force, scaling laws. The future's here, won't you come and see? Welcome all to GTC.
All right, have a great GTC. Wait. Thank you, everybody. See you, love.
I just met. I don't